Oh, yang ini. Eko, kenapa?
Satu dua tiga.
Oh, udah berapa?
Dengan gini aku. Ladies and gentlemen, the program will begin shortly, so we kindly invite everyone to be seated and prepare as we are about to start today's agenda. And to all virtual participants, thank you for connecting early. We kindly remind online attendees to ensure that their discussions follow the formatting institution and to keep their microphone mute during the presentation unless invited to speak. Thank you for your attention. Distinguished guests, ladies and gentlemen, good morning and welcome to the International Conference on Marine and Fisheries Science, ICMFS 2025. Dear Honorable, the Secretary of the Institute for Research and Community Service, LPPM. Dear Honorable, the Dean of the Faculty Marine Science and Fisheries, Udayana University. Dear Honorable, the First Vice Dean, Academic and Planning Division, Faculty of Marine Science and Fisheries, Udayana University. Dear Honorable, the Second Vice Dean, Finance and Resource, Faculty of Marine Science and Fisheries, Udayana University. Dear Honorable, the Head of Marine Science, Faculty Marine Science and Fisheries, Udayana University. Dear Honorable, the Head of Aquatic Resource Management Program, Faculty Marine Science, Udayana University. And all the staff, committee, and all participants, offline and offline. Our keynote speakers are Honorable Dr. Nani Hendiarti, Professor Josapha Tetuko Sri Sumantyo, Professor Saikitya, Dr. Maifan Tela. And our invited speakers today are the Honorable Dr. Manuela Capello, Professor Eric Gilson, Dr. Stefano Fignudelli, and Dr. Basir Ahmed. We are delighted to see you all here, ready to continue our journey of knowledge sharing, collaboration, and innovation. On behalf of the organizing committee, we hope you all enjoy this event and are ready for a day full of insight. Ladies and gentlemen, the first agenda is the traditional Balinese opening dancing from our student, that is Sekar Jagat Dance. Without further ado, Please welcome Sekar Jagat Dance. Please enjoy the show.
Recording in progress.
Ladies and gentlemen. Ladies and gentlemen, the next agenda is to sing the national anthem Indonesia Raya. For on-site may stand up and online may join if circumstances permit. For the committee, time is yours.
Indonesia tanah airku, tanah tumpah darahku. Di sanalah aku berdiri, jadi pandu ibuku. Indonesia kebangsaanku, bangsa dan tanah airku. Marilah kita berseru Indonesia satu. Hiduplah tanahku, hiduplah negeriku, bangsaku, rakyatku semuanya. Bangunlah jiwanya, bangunlah badannya untuk Indonesia Raya. Indonesia Raya merdeka, merdeka, tanahku, negeriku yang ku cinta. Indonesia Raya merdeka, merdeka, hiduplah Indonesia Raya. Indonesia Raya merdeka, merdeka, tanahku, negeriku yang ku cinta. Indonesia Raya merdeka, merdeka, hiduplah Indonesia Raya.
Please remain standing for the next agenda, which is the prayer. I will lead the prayer, and everyone is welcome to follow according of their own beliefs. May God always bless us. Thank you. The attendants may have a seat. Ladies and gentlemen, the next event is welcoming remarks. We respectfully invite the Rector of Udayana University, represented on this occasion by Secretary of the Institute for Research and Community Service, LPPM, Igede Hendrawan SSI MSI PhD, to deliver the opening remarks. To Professor Hendrawan, time is yours.
Ladies and gentlemen, and this for the business speaker, or credit speaker, respected the Faculty of Marine Science and Fisheries, the host of this conference, Professor Dr. Udayana. As the government representative institutional partner and collaborator, respective scholar, researcher, industry partner, and participant, ladies and gentlemen, Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Salam, namo budaya, salam sejahtera, rahayu. Good morning. On behalf of the Rector of Universitas Udayana, please allow me to convey his warm regard and highest appreciation to all of you for attending this very important international forum. The Rector simply apologized that he is unable to physically present today due to an official duty in Jakarta for another strategic university agenda that could not be postponed. However, he fully recognized the importance of this conference and has entrusted me as the Secretary of the Institute for Research and Community Services (LPPM) of Universitas Udayana to represent him and the university in delivering his opening remarks and to officially open this event. It is my great honor on behalf of Universitas Udayana to welcome you to the International Conference on Marine and Fisheries Science (ICMFS) 2025, held under the term Blue Synergy, Sustainable Development and Improving Community Welfare for Marine and Fisheries Sector. We are proud that this conference is conducted in a hybrid format, bringing together participants both on-site here at Universitas Udayana and online from various parts of the world. This conference brings together 101 participants representing 30 universities and institutions and 9 participating countries. A clear reflection of the strong global interest and international cooperation in advancing marine and fisheries science. At this important moment, we express our deepest appreciation to our distinguished keynote speaker, Ibu Dr. Nani Hendiarti, as a Deputy for Coordination of Food Affordability and Food Security, Coordinating Ministry of Food Affairs, and also as a head for Indonesian Association of Oceanology. Professor Josapat from Chiba University, Japan, Prof. Saikit Yong, Hong Kong University of Science and Technology, Hong Kong, Ibu Dr. Sayan Widyastuti, Universitas Udayana, Professor Stefano Pegnudelli, National Research Council of Italy, NR Italy. We also extend our sincere gratitude to our respected invited speaker, Professor Kim Pukyong National University, South Korea, Professor Susan Dobling from Brunel University, London, Professor Eric Wilson, University Côte d'Azur, France, Professor Stefano Pignudelli, National Research Council, Italy, Dr. Manuela Coppola, French National Research Institute for Sustainable Development, Dr. Bashir Ahmad, Institute of Forest Ecology, Royal Academy of Science, India, Professor Wayan Gede Astawakarang from Udayana University, and Dr. Mike Van Cullen from Murdoch University, Australia. Your presence, both physically and virtually, significantly elevate the academic quality and international stature of this conference. Ladies and gentlemen, this conference already bring together a diverse network of leading universities and institutions reflecting the breadth of national and international participation. Among the participating institutions are Annamalai University, India, Charles Sturt University, Australia, Southern Cross University, Australia, University of Montpellier, Malbec, France, Diponegoro University, Gajah Mada University, IPB University, Pajajaran University, Politeknik Pertanian Negeri Kupang, Sultan Ageng Rekayasa University, Universitas Airlangga, Universitas Brawijaya, Universitas Alulio, Universitas Indonesia, Universitas Lampung, Universitas Maritim Raja Ali Haji, Universitas Muhammadiyah Purwokerto, Universitas Muhammadiyah Sukabumi, Universitas Negeri Padang, Universitas Pendidikan Ganesha, Universitas Riau, Universitas Pulojoyo Madura, Universitas of Bengkulu, along with respected institutions such as Bendega Alam Lestari Foundation, Biodiversitas Indonesia, the Center for Fish Health and Environmental Assessment, the Para Brackish Water Aquaculture Fisheries Center, and National Research and Innovation Agency of Indonesia, BRIN. This strong institutional representation illustrates the conference wide academic and multidisciplinary reach. Ladies and gentlemen, this conference is not only a forum to disseminate research findings or exchange scientific knowledge. More importantly, it serves as a strategic platform to initiate a strengthened long-term collaboration among universities, researchers, academia, government institutions, and private sector. Through this synergy, we aim to enhance research excellence, accelerate innovation, and ensure that scientific outcomes translate into real and measurable impact for society, the environment, and economy. We envision that the discussion and networking formed through ICMFS 2025 will involve into joint research initiatives, technological development, policy formulation, industrial application, and community-based programs that contribute to sustainable marine governance and improve livelihoods, particularly for coastal communities. The marine and fisheries sector remain a vital pillar for food security, economic development, and ecosystem sustainability. However, the challenges we face, including climate change, overfishing, habitat degradation, and marine pollution, demand integrated cross-sectoral and multidisciplinary solutions. Therefore, collaboration between knowledge producers and stakeholders is no longer optional. It is essential. This conference strongly aligned with the United Nations Sustainable Development Goal, particularly SDGs 14, life below water, while also supporting broader objectives of inclusive economic growth, environmental protection, and social resilience. Universitas Udayana is committed to serving as a catalyst for scientific collaboration, innovation, and sustainable impact. We firmly believe that ICMFS 2025 will not only strengthen academic discourse, but also further strategic partnership that drive transformative change in the marine and fisheries sector at both national and global level. In addition, Universitas Udayana, through the Institute for Research and Community Services (LPPM), will further strengthen its commitment to scientific excellence in 2026 by providing dedicated research funding for academic staff. This funding will be mandatory for collaborative research activities. This funding will be mandatory for collaborative research activities requiring scientific of Udayana University to establish strong partnership not only with overseas university and international institutions, but also with strategic partners within Indonesia, including government, industry, and community-based organizations. This research scheme is designed to encourage interdisciplinary and cross-border collaboration that produce impactful outcomes, ensuring that research contributes meaningfully to academic advancement as well as tangible benefit for society, government, and the private sector. The call for research proposal is scheduled to be launched in mid of December. So we are as partner, international and Indonesian partner, can be proposed together with our academic staff here at Udayana University, marking an important step to foster innovation driven and partnership-oriented research initiative at Udayana University. In closing, on behalf of the Rector of Universitas Udayana, I once again extend our sincere appreciation to all keynote speakers, invited speakers, the Dean of Faculty of Marine Science and Fisheries as a host, government representative, institutional partner, participant, organizing committee member, and all stakeholders for your valued contribution and commitment. So I open up this session on behalf of the rest. Thank you. So with great respect and pride, I hereby declare that the International Conference on Marine and Fisheries Science, ICMFS 2025, officially open. Thank you, and this conference become a milestone in advancing collaboration, innovation, and sustainable impact for our ocean, our communities, and our future economy. Allow me to conclude this remarks with Om Santi 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 Om. Assalamualaikum warahmatullahi wabarakatuh. Salam, nama budaya, salam sejahtera, rahayu, rahayu, rahayu. Good morning.
Thank you, Professor, for the insightful and inspiring remarks. Ladies and gentlemen, the next agenda is group photo session. So we kindly invite on-site VIPs and delegates to proceed to the prepared photo area, which is on the front, and online participants to remain in the session for our virtual group photo. So please turn on your cameras when prompted. So for the committee, time is yours. So please, for the VIP delegates, okay, I will lead in count. 3, 2, 1. Maybe once again. 1, 2, 3. Maybe once again with another pose. Okay. 3, 2, 1. Okay. Or once again with the hand pose. 1, 2, 3. Okay, thank you so much. Okay, maybe the VIP delegates can come, so the participant can appear on the photos too. For the audience, please stand up or take a picture together. Once again, for the participant, please stand up to take a picture together. I count in 1, 2, 3. 3, 2, 1. Another pose, maybe? Again, 1, 2, 3. Okay, then. Thank you so much for your attention and please take seat. Ladies and gentlemen, the next event is Keynote Speech Session 1. We begin Keynote Session 1, delivered by three keynote speakers, that is, Professor Josaphat Tetuko Sri Sumatyo from Chiba University, Dr. Nani Hendiarti from Indonesia Association of Oceanologists or Coordinating Ministry for Food Affairs, Professor Saikit Yap, Hong Kong University of Science and Technology. And this keynote speech will moderate by Made Narayana Adibusana, PhD. So, without further ado, please welcome Made Narayana Adibusana, PhD. The time is yours.
Morning, ladies and gentlemen. Welcome to this keynote session of our international conference. It is my pleasure to serve you as your moderator today. And we have an exciting lineup of keynote speakers who will share their insight on advancing science, technology, and innovation for a more resilient and sustainable future. To begin, let us proceed with our first keynote by welcoming one of the world's leading figures in microwave remote sensing and disaster-related geoscience. As extreme natural events continue to challenge our societies, advancing interdisciplinary technologies has become increasingly essential, and today's keynote will highlight a pioneering initiative grounded in decades of scientific leadership, innovation, and global collaboration. We are privileged to have with us Professor Josaphat Tetuko Sri Sumantyo, a full professor at the Center for Environmental Remote Sensing, Chiba University, Japan.
Hello, do you hear my voice?
Yes, Sensei, very clear.
Okay, yeah. May I start my keynote? Sorry, could you, I request I want to share my slide. Yeah. Okay, may I start my keynote? Bapak Narayana, do you hear my voice? Okay, yes, I want to start my keynote today. Yeah. Okay, my name is Josaphat Tetuko Sri Sumantyo. I'm a professor in
Prof.
Center.
Yosafat,
Yeah.
can you hear me? I
Yeah.
think we have a technical problem. Please wait a moment, maybe 1 or 2
Okay.
minutes. I will let you know soon.
Okay, yeah.
Please wait a
Thank you very
moment,
much.
Prof.
Okay, yeah, thank you.
Hello, Professor. Can you hear me?
Yes, yes, I hear you. Yeah. It's very clear, no problem.
Hello, Professor.
Yes. Yeah.
Okay, Professor. Please start your presentation, Professor.
Okay. Yeah. Okay. Thank you very much to Bapak Narayana as the moderator. Yeah. Okay. First is I want to thanks to the all of the committee and also the rector of Universitas Udayana, Professor E. Ketut Sudarsana, and also Professor Indrawan as the representative and the dean of the faculty of the fishery and oceanography, Professor Iwayan Nuarsa. My name is Yosafat Tetuko Sri Sumantyo. Right now, I'm the full professor in Center for Environmental Chiba University and also at head division right now in the faculty of the medicine of Chiba University and also head division of the health and disease omics center in the faculty of medicine of Chiba University. For the detail is you can find in my laboratory link here, and also my laboratory is Yosafat Microwave Remote Sensing Laboratory or JMRSL in Chiba University. Okay, for the details you can also find in my books that you can find in Tokopedia or Shopee in Indonesia. Okay, today I want to share to you about our recent research. Yes, I think this research also have the relation for the blue technology that we can apply for the oceanography application. Okay, and the title is establishment of an interdisciplinary hub for the AI disaster mitigation and sustainability. Like you know, Indonesia and Japan, this is a little bit similar that we are surrounded by the sea. That the sea is also generated many disaster for Japan, especially uh, for the typhoon, yes, and also the subduction in the southern part and also in the eastern part of the Japan that generate the earthquake. Then we want to manage the disaster itself. Yeah, if possible, is predict the disaster before the disaster is. We hope we can predict and reduce the disaster itself. And we develop many advanced technology for the microwave, especially for the remote sensing. That here is what we developed until right now. Yeah, we developed the 6 meter of the UAV for the synthetic aperture radar and also the optical sensor. Yeah, inside our UAV. And now we also developed the high altitude platform system that with the height is 15 kilometer until 25 kilometer. That this is we can reduce our budget. Yes, compared to our microsatellite that we spend some million US dollar, and I hope we can reduce this the cost itself. And we also develop many radar for the CN235 aircraft and also for the Boeing 737. For the detail is you can also read from my books here published by the CRC Press and the IEEE entitled the Airborne Circularly Polarized Synthetic Aperture Radar. Okay, for the topic, on the hot topics, yes, nowadays for the science and technology, especially today, our topics about the blue technology, yes, and here is I just pick up several know this, the most advanced on the trend of the science and technology. First is about the energy and climate, and you can find here is for that the trend right now, and I think it's have related with our symposium today is about the next generation renewable energy, because here is including the floating solar and also the offshore wind. Yes, this is have the from the oceanic technology, and the other one is about yeah, green hydrogen, ammonia economy, and carbon capture, utilization and storage. Yeah, and also for the carbon capture itself, as we use the remote sensing technology right now, is uh, having the relation from the carbon neutral itself. Then I think is you can find in our center, for example, the data of the human Maori 8 and also 9, that we can get the data every 10 minutes, and it is a free of charge. If possible, is if you want to use it, please uh, check the link to the Center for Environmental Remote Sensing in Chiba University, and you can get our data for more than 25 years long, and I think it's a very detailed data. And the other one is about the environmental and earth system, and this digital twin earth, yeah, and climate resilience modeling is have relation with our research right now, and we develop the digital twin for the especially for the disaster monitoring. And nature-based solution, I think is for the topic today is have relation with the blue carbon ecosystem, especially in the mangrove and the seagrass itself. Yeah, and also the geoengineering debates. Yes, this one is uh, uh, especially from the ocean iron fertilization. Yeah, it is. I think Indonesia almost uh, two-thirds of our area is ocean. I hope we can develop many technology that to get the resource from the our ocean. Yeah. The other one is about digital transformation and industry 5.0. Okay, I will skip this one. And next is the frontier and global collaboration. Yeah, and right now, yes, I think you know that Chiba University and University of Udayana, we have a long history, yeah, including the establishment of the crash source itself, and also we running the double degree program. Yes, and I hope some of you can enroll to our university under double degree program with the Universitas Udayana and Chiba University. Yes, especially focusing on the remote sensing technology. And I think you can also find the topic, yes, related the ocean exploration and blue economy. Yeah, here is sustainable fishery, maritime or marine renewable energy, and ocean biomaterial. Okay, and next I want to focus for my topic that about the digital twin. When the background is like shown here, Chiba area, Chiba prefecture that attacked by the Typhoon Fasai on 5th September 2019, and this one is I think is generating the extensive damage, yeah, particularly in Chiba prefecture, yeah, and almost half of the Chiba is destroyed by this Typhoon Pasai and 2000, and also last year, yes, Noto Peninsula earthquake, yes, on 1st January of 2024, and this one is also destroyed the building, especially in the road and also in the port, yeah, because the port is uplift 4 meter, and right now we cannot use the port itself because the port is to be land right now, yeah, and now we consider about how we could predict the earthquake and also the typhoon itself. Okay, many researchers already developed some prediction, yes, but it's not so accurate, yeah. So because we need the information 24 hours after the the disaster itself, and at least 3 days or 72 hour, yes, after the disaster itself, and how to manage the disaster area, and also including how to recover people, inside the disaster area. So in this case, is I try to start the pioneer in the field of the AI-based disaster mitigation and sustainability study. Yeah, I established this a study 2 years ago, and including the it's not just the research but also the education. So we want to educate the people on the student that they know about the AI-based disaster mitigation and sustainability. Yeah, I hope some of the student, master and doctor student could enroll to this study and join us. Yeah, because this study is integrating the remote sensing, data science, disaster prevention, meteorology, geophysics, disaster medicine, and social science. Social science is, I think, is until right now, it's not so many people can, merge between the science, science is mean the engineering, yeah, engineering, technology, and the social science. Now I want to try to merge all of this field in one project or one study. Yeah, I hope we could enhance the disaster prediction and prevention function. Yeah, by using the this interdisciplinary hub for the AI-based disaster mitigation and sustainability study. Yeah, and I hope we could realize, and help many people within 24 hours post the disaster, at least is 72 hours. Right now in Japan is already winter season, yes, and very cold, and if the disaster happen, I think 24 hours is the golden time, yes, to save people. If we could not save this one, as many people, die. Yeah, and how to realize this one? And I established this one. Yeah, the AI disaster mitigation study. This is include the platform of the AI. We call in the digital twin. We we want to simulate a real time, yeah, the condition of the disaster itself. Yeah, and here as we used many data. Yes, so why we established the big data in Chiba University, using especially in the Himawari 8 and 9 from the Japan Meteorology Agency, and also from the JAXA, yes, LOS, many LOS data we use here, and also we developed our own the UAV. Yes, this UAV is we want. I hope we could replace the satellite function. Yes, in the future, and we also collected the data from the agent. Yes, and we realized the digital twin, and I hope using the control AI we could at least as we could design the safe route for the medical team, firefighter, and also disaster prevention team, and also the Japan military to help people, yes, as soon as possible, because we already have many experience about this large disaster in Japan, and we also develop the system with the insurance company like the Nissay and some another company that the disaster and the insurance is very close, and we need to integrate this system together. Yeah, and we work together with the Chiba prefecture, yes, and also Chiba city, and we start this project to give the a good example for the people that university and government, and also in the local government like the Chiba prefecture, we work together how to solve the post disaster problem. Yeah, and I hope we have a 5-year project, and this year is the second year, and I hope in fourth year we will implement this system for whole of the Japan. And we work together with also the national Taipei University and also the France, yes, France first university at Paris, yeah, and also the some institution in Indonesia. I hope we could work together and include you, yes, from the University of Udayana. If you have interest, you can join with our project. Yeah. Okay, this is the group itself, big data, yes, and also the crisis navigator navigation. It is from the social science, and the third one is from the spatial AI. This one in the digital twin implementation, and here is social demonstration. We work together with like the NGO, yes, and so on, is work in a group for. And the last one is, this one is for human resource development. Yeah, and here we work together with many university, and we established the new course, yes, for the master and doctor course for the digital mitigation and AI based digital twin. I hope some of you can join here too, and we could learn together how to solve the disaster. Okay, this one the detail I want to keep, and here's the roadmap in our laboratory. Yes, to develop the advanced technology here. Yeah, we already developed several microwave remote sensing technology, and also the drone itself, and we already installed in the CN-235 aircraft, Boeing 737, and we also developed the microsatellite, and we also flew in our UAV. And this year, we will finish 3 new radar, PLCX band, and I hope we could also make to collect the data of the disaster itself, any place. Yeah, and here we also develop the sensor to destroy the typhoon. I hope in the future we could realize the zero typhoon in Japan using our sensor. Yeah, and I hope we can also implement in Indonesia too. Yeah. Okay, and I saw this one is what we already developed in Yosafat laboratory. If you want to see in the Yosafat UAV in YouTube, yes, and here is we install the uh, drone. Inside drone is the uh, synthetic aperture radar, especially in the circularly polarized synthetic aperture radar. Now we already have the PLCX and K band. Yes, I think it's very complete. Yes, even in Japan, is maybe just in our laboratory we have the complete radar. Yes, for the drone and airborne, and also for the satellite, especially in the microsatellite, because we already developed the microsatellite synthetic aperture radar since 2005. Yeah, and then now is many people already use our technology. Yes, to realize the synthetic aperture radar on board the uh, uh, with many platforms. Okay, and I think some of you already know about the remote sensing, and remote sensing is, you know, especially classified by the optical remote sensing and microwave remote sensing, and we focus on the microwave remote sensing here. Yeah, and the optical is depend on the light, especially in the sunlight. So why it's just working in the daytime. Yes, in the nighttime is we could not use this optical sensor. So in this case is we need another sensor we call in the synthetic aperture radar. Synthetic aperture radar we transmit by ourselves and receive by ourselves. So we call as on the active sensor. You can find here is the first circularly polarized synthetic aperture radar by my laboratory, or Josaphat Micro Remote Sensing Laboratory, JMRSL, that we collected in the first in 2018, and I hope from next year you can find the more advanced circularly polarized synthetic aperture radar using the PLCX band based on the drone or UAV, and also for the aircraft. Compared to the optical, you can find when we flew here it is in the Lanut Hasanuddin at Makassar. Yeah, it is without the the cloud, and you can find if you collect using the optical sensor. This is with the cloud, and you cannot find the information under this on the cloud. Yeah, okay, but it's not just the could penetrate in the cloud, but also could penetrate under surface. Yeah, for example, here is at the uh, uh, underground river at southern part of the Egypt, and you can find here in the underground river by using the synthetic aperture radar. For the detail, you can read our paper, yes, at the IEEE and also the International Journal of the Remote Sensing. Okay, on the optical sensor, it's very easy because the wavelength is almost same with our human eyes. Yes, and also easy understanding because the scattered of the sunlight. Yeah, but the SAR sensor it's very difficult because the wavelength is more longer compared to the optical sensor. And here is also the mechanism is very complicated and so many distortion. But the information from the synthetic aperture, you can get the intensity, phase, and the polarization. So I want to show you about the many application of the synthetic aperture that we already developed in Yosafat Laboratory or JMRSL. Here is the sensor that we already developed and installed on the Boeing 737 CN235 aircraft, Cessna, and our drone, and we also have the new drone, and here from the micro satellite. Yeah. We transmit the circular polarized, for example, here in the right-handed circular polarization on the RRCP, and scattered, you can get the LHCP or left-handed circular polarization and right-handed circular polarization. After you process, you can get the intensity, phase, and the polarization. Okay, for the detail, I think I wrote very detailed in this paper in IEEE and also in the my books, yes, published by the CRC. And I also have the patent about this my sensor. Yeah. For the detail of every sensor here, for the circular polarized synthetic aperture for the microsatellite, you can read my book here, Radar Remote Sensing. And for the airborne is this one, airborne circular polarization. And also for the drone is autonomous control system and vehicle. Yes, I hope here is many young students, young scientists. I hope please don't forget to write the books. Yes, every result of your research. Yeah. I want to show this what we did in Indonesia. Yeah, we did it in many place, and okay, here is in Indonesia. It is with my student from many country, from Germany, Japan, Malaysia, Indonesia, and so on. Yeah, when we install 5.2, yeah. And here, and the material of the radome now is used by the big company in Japan is on the SoftBank. Yeah. Okay, and here when we install in the CN235 aircraft, yes, with the full polarimetric synthetic aperture radar, you can see here the transmitter, right-handed circular polarization and left-handed circular polarization, and same yes for the receiver here. When we install in CN235 aircraft, and here inside the aircraft itself, and we got the first in the world for the circularly polarized synthetic aperture radar. This is my invention, and the first image in the I think historical image in the remote sensing field. Yeah. Yeah, here in the full polarimetric data. Yeah, and you can find compared to the linear polarization. Linear polarization is the co-polarization is very strong, but the cross polarization is low. But the circular polarization is opposite. Yes, it is our finding. Yeah, and then you can extract this data and you can use for many new application. Yes, in the future. Now why we develop the circular polarization, and now is the Chinese Academy of Science already also improve my technology, and they show that the circular polarization is more sensitive compared to the linear polarization. And for the application, you can find it is. I want to show you in the interferometric SAR. Yes, for the differential interferometric SAR or the INSAR, and also the polarimetric SAR. Yeah, and here is for the INSAR. Yes, for example, we use the chairs one. Yeah, it is the Lapindo. You know the Lapindo, the subsidence Lapindo. Yeah, here is first is we select the two data before and between the disaster itself. We make the geometric correction. After that, as you multiply, and you can get the interferogram, and you can reduce with the simulated orbit pattern, because inside here still the orbit pattern is remain, and then you can get this image. Yes, we call as the eliminated interferogram. And compared to the previous data, and you can get the, we call as the deformation phase error. Yes, you can get, you know, this area actually in the lens subsidence in the Lapindo on the Sidoarjo area. And if the data is very clear and good, you can also extract the DM or digital elevation model. Yeah, it is the real change on the surface of this subsidence area at the Lapindo or Sidoarjo area. Yeah, and by using the face, only in the face, you can get the lens deformation, yeah, including the building deformation. Yeah, for example, in the Central Java earthquake, yeah, you can use the coherent analysis, just the phase information. You can get the change area. The red one is the destroyed area, the building destroyed, and the blue and also the yellow is mean the safe area. Okay, and it is last year, yes, that happened in Noto Peninsula, yes, uplifted, yeah, uplifted. You can see here, it is the part before the earthquake, and here after the earthquake. So we cannot use the port right now because the port is already uplifted, like shown here. Yeah, 4 meter uplifted. It is a very huge earthquake, and here is the, you know, the uplifted. Here before is under the sea, but now you can find is now it's already uplifted, and here in the port is we cannot use. Yeah, and I analyze using the INSAR. This part is 4 meter uplifted, and this area is 0, and here is, you know, subsidence. And we also could employ this technique as for the volcanic eruption. Like last 2 days ago in the Semeru, Mount Semeru already erupted. And here is, for example, the example for the Mount Merapi. Yes, when the eruption, you can find, you know, the sedimentation of the wet lava in this area. Okay, yes. This technique, I think, is not so difficult, and you can use this technique and improve this technique to, for example, to estimate the volume of the sedimentation, and also the destroyed on the collapse area using this technique. And I also have the project with the Malaysian government, yes, to monitor the East-West Highway in the Malay Peninsula, because this highway is surrounded by many hilly, you know, area that here we monitor. For example, this area is every year about 5 centimeter moving. Yes, you know, in 10 years is already, you know, 50 centimeter. I think it's very dangerous. And what happened in this area is already, you know, landslide already happened. Yeah. Then when we monitor, it's like this one with my student in 2014. Yeah. Okay, this is our new synthetic aperture radar for the drone, and with the PLC band in one drone. And I think it's very complete, and we realized for the circularly polarized synthetic aperture data from the multi-band drone SAR. Yeah. And before I close my talk, now I built the new Yosafat laboratory in Boyolali in Central Java. This is a 5-hectare research center in Indonesia. I hope we can continue our activity in Japan, and I want to establish in the northern part, in northern of the Lanut Adi Sumarmo, Bandara Adi Sumarmo at Solo, about 15 minutes. Yeah, we will establish many sites here from the drone and radar, and also in the health, fishery, agriculture, and so on in one place, 5-hectare facility. And the name of center, our center is the Infinity Innovation Center under the Josaphat laboratory. I hope within 10 years before my retirement, I will finish this facility. And we already start from this year, and I hope gradually we will build our facility here. At least it's our main office here. We will finish next year. Okay, thank you very much for the opportunity to give the keynote speech today. I hope you can get idea from our research nowadays. Yeah, thank you very much. And if you want to know detail about myself, and you can find the books in the Shopee or Tokopedia, yeah, entitled in the Meraih Cita-Cita Setinggi Angkasa. Thank you very much, and I give back my time to the moderator. Thank you.
Real-time monitoring disaster service subsidized as well as the recent disaster in Indonesia, Mount Merapi eruption. And now we have a discussion session for the audience, either here offline or online. If you have a question, please raise your hand. Okay, any questions? How about online participant? Is there any question? Okay, there's one question from Dr. Hendra.
Hello. Hello, Josaphat. Nice to
Yeah,
meet you.
I heard your
Again
voice.
here.
Yeah, thank you. Yeah.
Yeah, you well there. So yeah, it's really interesting presentation you had today, and yeah, I think you have to go advanced remote sensing in Siwa University, and I think it will be really fruitful if we can do like a testing of your product here in Udayana University. I want to know how then we can developing our collaboration more strongly with our university in Udayana, so we can work together in regard to how then we can yeah, like a testing of your product, your technology, and then maybe we can validating what you are doing there, and how then we can developing technology together. As you know, our university also have a role how then we can encourage of our academic staff here to produce to do more innovation and trying to applicate of the technology that will be impactful for the society or for the government. So I wanted to know how then we can start to collaborating with a new project you have there, and collaborate with us in Udayana University. Thank you very much, Professor
Yeah.
Safa.
Yeah. May I answer? Yeah. Thank you very much, Professor Hendrawan. Yeah. Yes. Actually, Chiba University and Udayana University already have a very long collaboration under the research and education. Yeah. Because I manage this collaboration, I think it's more than 20 year. Yeah. And many students is already exchanged with our university. When I established the short stay, long stay, and now one of the student, yes, from Udayana University, also under our double degree program. Yes, now study in my laboratory, and I hope we can continue. Yes, especially we have many advanced sensor, and maybe we can arrange the joint testing of our sensor in Bali. Yeah, yes. This year, December, we will finish our sensor, and I hope we can bring our sensor to Bali, and then we can monitor. Yeah, maybe we can decide the topics. Yeah, the hot topics that interesting for your side and also for our side. Yeah, and I think we are welcome. Yes, to do the joint collaboration. And please also try use our database. Yeah, we have the data of the Himawari 8 and 9. Yeah, for more than 25 years. Yes, and you can use our data because this data every 10 minutes. Every 10-minute data of the satellite is I think it's very detailed. And then uh, uh, from Udayana University can use this data for the the microclimate, weather forecast, and also for the agriculture, for the fishery, and also for including for the the accident. Yes, accident. Now we develop for the turbulence. Yes, and also sometimes the volcanic eruption at Lombok area or surrounded area happen, and then will give a big impact to the tourism field in Bali. Yeah, and we can predict. Yes, sometimes it's safe, but and the airplane cannot reach the Bali. Yeah, I hope you can also use our data. Yes, we are welcome. Yes, for the collaboration, and I hope we can talk more detail. Yeah, because we already sister university between the Chiba University and Udayana University. So please use this opportunity as best as possible. Yeah. Thank you very much, Professor Indrawan. Yeah, thank you. Yeah.
I'm sorry, we have a technical problem with the connection from the server. I hope it can. My voice. Hello, Professor. Can you hear me?
I'm sorry, I could not hear. Yeah.
What about now?
Okay, okay.
Can you
No, it's
hear me
okay.
now?
Yeah,
Yeah, yeah, that's really interesting. So, yeah, I believe you know about the disaster, the last disaster get Bali. The latest the floor on of building also uh, yeah, that's planning as the root of the disasters of last time. So I think it really interesting that we can do collaboration collaboration in next year, 2026. If we can collaborate, how then we can giving a combination to the local government here through the satellite and technology and capturing the problem in the along of the river, for example, and also the how the land use change has already happened within like 10 or 20 years. Important information that will be changed the policy maker to making a policy in the future. So yeah, I think next to our disaster in the future. Thank you for your answer.
Yeah. Thank you very much. Yes, and maybe I can share one of our project right now that we work together with also the pemerintah daerah Jakarta and also pemerintah daerah Jember, yes, and also Aceh. Yeah, now we run the our digital twin for the disaster monitoring in this three area. I hope in the near future or from next year we can work together for the Bali area. Yes, maybe we can establish the digital twin for the Bali area, and then we can install the data almost all of the data on the remote sensing and also the local data in this digital twin, and we can know real time the condition of the Bali area. Yeah, thank you very much. Yeah.
Thank you for the answer, Professor. Committee, do we have more time for question? So no more time for this session. So once again, thank you very much, Professor Josephat, for the insightful and inspiring presentation. So we hope that our next meeting we will talk about our collaboration in adapting and applying this technology in Bali. Thank you very much, Professor.
Thank you very much. Oh, yes. Keep in touch and keep
support and support. We are privileged to welcome Dr. Neni Hendiati, who is Deputy for Environmental and Forestry Management, the Coordinating Ministry for Maritime Affairs and Investment of the Republic of Indonesia, and also as the head of the Association of role of climate-related and to government decision making. Through her leadership, for coastal conservation, sustainable resource management, and effective multi-agency coordination. This journey
Recording in progress.
Good morning, everyone.
Oh, hello, Dr. Nani. Good morning.
Yeah. Yeah. Thank you very much. So first I would like to make sure that my voice, you can hear my voice clearly. Pak
Yes,
Dik?
we can hear your voice very clearly.
Okay, because I actually cannot hear clear your voice, but if you can hear my, then it's okay. So okay, yeah, okay. Can I start? Yes, I think first of all, I would like, so it's like echoing, yeah. Three. So check the mic. Iya, coba boleh. Terus sama echo. Maybe my team can share the slide if okay. Sudah. Yes, I think I would like to begin for the greetings. Yeah. Very good morning. Om Swastiastu. And I would like to also greeting to the Professor Ketut Sudarsana as an rector from the Udayana University, and also Professor Iwaya Nuarsa, Dean of Faculty for Marine Science and Fisheries, University of Udayana, and also the Professor Josaphat. I also just joined, and I it's from the Chiba University. I think long time not see to meet the Professor Josaphat, and also Professor Sai Ketiu from the Hong Kong University of Science and Technology, and all the invited speaker, expert, participants, friends, and ladies and gentlemen. First of all, I would like to say that this is an honor for me to be here to join the important international conference on the marine and fisheries science, and apologize that cannot attend in person because of the other agenda in Jakarta, and also because of I just arrived from Belém for COP30 in Brazil. So for this special event, as we can see here, I think beside as a deputy coordinating minister for road accessibility and safety, I also I think in the capacity of the as a chairman of the Indonesian Association of the Oceanologists. So I think I would like to give appreciation to University of Udayana for making this international conference on the marine and fisheries science, and also with the specific topic on the blue synergy, sustainable development, and improving community welfare for the marine and fisheries sector. I think this is very important and in line what we have also in the government priority program, as well as we have discussed in the Indonesian Association of Oceanology. Next slide, yeah. Next slide. So I think I would like to begin very short. This is just to show all the speaker and also participants and friends. I think we already know, but just need to remind always like how is the Indonesia has the great potential and opportunity specifically on the marine and fisheries sector. but I think we know that to utilize these big resources, definitely we need science and innovation. Yeah, we have. I think in this international conference we will discuss this topic, and this is very important because why science and technology is very important and necessary to be always update and discuss and update, but also implement it because we have many challenges. So if we see the next slide, I think we can, sorry. Yeah, so next, right? Yeah, I think we can see that what we say that the climate crisis, yeah, climate crisis has become also one of our challenges, yeah, and we can it really close to the topic that we will discuss today. Uh, because of one of the issue that our President Prabowo brings to the UNGA, United Nations General Assembly, in September this year, that Indonesia is really experiencing in context of how devastating effect of the climate change, with the case of the sea level rise, specifically in the northern Java Island, because I think, but not limited to this North Java, but specific for the North Java Island, because we have also other issue, yeah, they're making the coastal area in the northern Java have more pressure, not limited to the climate change due to the sea level rise, but also with the issue on the land land, what call it, and from the coastal area because of the rivers, yeah, pollutant, and also the land subsidence, and also the land use change in the coastal that originally covered by the mangrove, so change to the other program and not the other activities by the people. But now we are moving to how to integrate it all to making better in the coastal, as we call it, the coastal resilience program. So next, I think beside that issue in the sea level rise, which has close connection to the marine and also fisheries sector, we also see that the climate change also give the impact toward the food security. Why? Because I think we understand that the occurrence of the extreme weather and also hydrometeorological disaster can also give the impact to the food security. Specifically, if we see here in the slide, the agriculture area that cover about 40% of Indonesia can get this impact. But also it's not only in Indonesia actually, but also in the global. Yeah, this issue is cover also this issue. Not only in agriculture, in terrestrial, but also in fisheries production. I think we can have also more data from the Ministry of Marine Affairs and Fisheries that they can globally give an impact like decreasing about 2%, but also in Indonesia we get also the impact on this topic. Yeah. So next. So I think we would like to focus on the issue. I think two issues. Yeah, why? On specifically on the impact to the or the situation in the coastal and also what we call it, the small islands. Yeah, and I think it is the first issue that I would like to raise in this topic, in this important event. So first, why the coastal and small island is very important for us related to the as an archipelagic countries, because we see here that the sea level rise also happen not only in the coastal area but in small islands, like there are 111 other small islands in Indonesia are very vulnerable on the climate change impact to the increasing sea level rise. Yeah, so because this will also give the impact to the other such like um, the to economic activities like marine tourism, and also in some cases also because of the rising temperature, they happen the what we call it coral bleaching. Normally we have like every 4 years in one place, but now we have more frequent, and also in larger cover in the larger area, like in also in the eastern part of Indonesia. Because before it always only impact to the central and the west part of Indonesia. But now, since I think since 2000 and maybe around 2010 or 12, so the bleaching also happen or occur in the eastern part. But because of the uh, Indonesian true flow makes the recovery in the eastern part is faster than in the other part. So I think this all is actually based on the data and also science. Yeah. So how important science and innovation in this context, I think we can see. So next slide. Yeah. We would like to what to call it, to discuss here. We hope that because of we understand the climate change gives an impact to Indonesia, but we see what is the urgency of the climate change integrated database system. So we in the governments we have the database in different ministries and agencies. Like you see here in KKP is Ministry of Marine Affairs and Fisheries, as well as in the Ministry of Environment (KLH), and also Ministry of Forestry (Kemenhut), and others like BMKG. They have also many data related with the climate change, and also Agency for Science and Innovation, or BRIN. Yeah, we call it BRIN. So I think what we need is how to integrate all the database become once we call it the climate change database, and we see here that the urgency that we need the surveillance system in a near real time climate change control system in dashboard is very important, because this will integrate the crucial and real-time data, from the different parameters and different aspects. So we hope that we can work further, make it a collaboration on this issue, because we actually we have already, like in BMKG, Agency for Meteorology, Geophysics and Climatology. But I think we need to integrate with the sector where we have also parameters under the ministry, sectoral ministries, like I mentioned before. So we can make this all the data, then later we'll produce what we call it, or to improve our early warning system, and also to anticipate the policy making on the climate change impact. So I think this is the first issue that important, and we need to work together, not limited to the Indonesian ministries and agencies, but also we need the support from the international strategic partner, like I think the researcher and academici from the others countries. I think we maybe we hope that we can have a discussion during this conference, and we'll come up the recommendation on this topic. Because I understand also that Indonesian through flow is one of the key that we can also improve our observation system. And of course through the collaboration and international collaborations, because one of the parameters measure from the buoy in the Western Pacific, that data can be used as an indicator of the evidence of the El Nino La Nina. So I think kind of this, I think we need to improve and to expand our collaboration. Next slide. And and the second one, this is about it. This is about more the to protect the coastal ecosystem, because we understand that the coastal in Indonesia is very important, and we need to have more concrete program on the what we call it, what we call the coastal resilience. And one of these program is the blue carbon ecosystem. So we have mangrove, 3.4 million hectares, and we have also seagrass, 1.8 million hectares. So we need to have like what we call the action plan on the blue carbon, with the targeted the ministries, but also the international strategic partner. And because we need to work on the main issue related with the protection, and also the biodiversity, climate change mitigation, and provisioning services. So I think this is the second topic that would like to raise in this event. So next, so we have already what we call the collaboration for sea and coastal resilience, such like Indonesia and BCAP. NBCAP is National Blue Carbon Action Partnership. So this already launched maybe I think about 2 years ago, and now we have already defined what we call the action plan. But basically, this collaboration and BCAP is a platform for our collaborations. So we need this to integrate all the resources for strengthening the blue carbon ecosystem into the national food security and climate resilience strategy. So the platform is not limited to the only government, local governments, but also the academician, expert, and also the private sector and social community. This also can involve in this platform. So next slide. So we'll describe a bit more detail about the NBCAP. So because as I mentioned before, there's already action plan specifically on the protection and management of the blue carbon. We are focusing on the 5 strategy. The first is on the spatial planning and region, and the second one on the policy and program for enhancing carbon reserve in the blue carbon ecosystem. And the third on the modalities for integrating blue carbon into our commitment to reduce the carbon and we call it NDC, National Determined Contribution. And also number 4, strengthening policy to support seagrass inclusive, because we have been working for longer with the mangrove. We already established the data, but also we want to move to the seagrass. So seagrass under the Ministry of Marine Affairs and Fisheries is working more intensive in this topic. And the last is about the governing of the blue carbon ecosystem utilization. So to achieve the blue carbon performance and climate resilience development. So I think this is important because we have also target that to implement this action plan. We already identified the specific target, how much we want to what to call it, rehabilitate the mangrove and so on. So I think there are a few. I can ask for if there's a question on this, but we also already identify how big the finance that we need. So we identify around like almost 500 million US dollar to implement this action plan within minimum 5 years. Yeah. So next is about 5 years program. Next slide. Yeah, and I think this is
Bu Dr.
yeah.
Indian, we are kindly remind you that we only have 5 minutes
Okay.
for presentation.
Okay, thank you, Pak Gede. So I think this just mentioned that the handicap action plan is also support the enabling condition on the unlock investment to this ecosystem. Yeah, I think the second topic, so I need more 3 minutes maybe. Next slide. This is the third topic, yeah. This is only summarize what we already prepared related with the blue carbon ecosystem to support the coastal resilience. I think we can discuss if there's a question on this issue. But the third topic, I would like, next slide, would like to mention in this topic is related with the marine plastic waste. As we know, this is a transboundary problem and also threaten the environment, also socio-economics. So I think in this international conference, it will be great if we can have discussion specifically on this issue, because as we understand that the impact on the marine plastic debris is large scale and also long-term damage to the marine ecosystems and biodiversity. So we identify already the potential impact as we can see in this slide from the loss of marine biodiversity, also microplastic entering the food chains, also to the economic growth and social community impact. So next slide, I think 2 more slides. Yeah, and what we have done since like 2018, what we call it, NPOA, so National Plan of Actions, by maybe about like 16 ministries and agencies, also universities support very much on this topic. Then we can achieve the what to call it, the target, not yet to 70 to reduce to 70%, but we already achieved to reduce the leakage of the plastic waste to the ocean about 42%, which is about 360,000 tons. It's a big effort for this. But the behind of this effort is actually science and modeling of the how the distribution of the the marine plastic debris. And now I think before on the 2015, from the Professor Jana Jamik mentioned that Indonesia potentially become the number 2 contribution. But after this effort, we can have by the new publication, I think like few years ago, 2 years ago, that already mentioned that now Indonesia is improved is about number 5. So, but I think we need to still to discuss about this, and this is heavy in the science and innovation. So last slide. So maybe next slide. Yeah, I think this is from me. Would like to highlight 3 points. Yeah, from this conference, international conference. I think really important to have what we call it the multi-stakeholder collaboration between national and global, international, specifically also in science and innovation. And the second one is important of the data integration, as I already mentioned before. And the last is also important, I think, need to be also discussed in here and come up what specifically need for improving the capacity on the coastal human resources, and specifically from the marine and fisheries science, yeah, to link with this issue. I think this is my what call it message to all the participants, and also specifically for the invited speaker in this international conference. So thank you very much for the opportunity, and very welcome for the discussion, and also the maybe question. Feel free to contact us, me as a deputy, and also as a chairman of the Indonesian Associations of Oceanologists. Thank you. I give it back to Pak Gede. Yeah, thank you.
Thank you, Ibu Dr. Nani Hendiati, for the presentation. And how many questions that we have for this session? Okay, I think only one question. Is there any questions from the audience, offline or online? Okay. Please introduce yourself.
Thank you. My name is Andreas Sumire. I'm from Indonesia. Thank you for the presentation, Ibu Nani. I'd like to ask about regarding Blue Carbon program. So, but the program, how the university or NGO can also participate in this program, and what of the ministry will be addressed for this program? Is it in the Marine and Fisheries Ministry or other ministry? And also, what is the expectation from this program that as university or NGO can also join for this program? Thank you.
Okay. Yeah.
Okay, Ibu Dr. Nani, please, you can answer the questions.
Yeah. Thank you. Yes, I think first in the Blue Carbon program, as I mentioned before, the university and NGO can involve. So how we can make it through two approach. First, if because we have already like platform, what we call the NBCAP, so you can involve from that platform, and this platform coordinated by the coordinating ministry for food affairs. Why us? Because I think this is continuing from the coordinating ministry of the maritime affair and investment. When I was working also in that ministries before as a also and handling this issue. And also the reason also the Ministry of Marine Affairs and Fisheries, Ministry of Forestry, and Ministry of Environment is under our coordinating ministry. So and the issue on the blue carbon is specifically in more comprehensive way, if we see, is cross ministries. Yeah. So the platform you can join or involve through this platform. But second one, for specific target, like I mentioned already, like seagrass, mangrove, The specific and the more technical issue is led by the Ministry of Marine Affairs and Fisheries. But we can link, this is actually, there's a linkage between two. Yeah. So because the Ministry of Marine Affairs and Fisheries also under NBCAP. So please welcome to join and you can contact to the secretariat, because we have a secretariat of the NBCAP. You can ask my team, and there's a team there. And yeah, I mean, we have already like a action plan, so we can share the action plan to you, and you can request the team. Yeah, I mean the team from the NGO and also from the university can request in which part you are willing to participate. Yeah, so then we can arrange, because I think regularly we have a meeting on this, and we also plan to have like next meeting because of the from the COP30 there's some.
Sister, we need,
Thank you.
as you mentioned last time, for multi-stakeholder collaboration.
Yeah, thank you so much. Thank you very much to everyone. Thank you.
Please be proud to be a gentleman. Thank you. Okay, ladies and gentlemen, we will now move to our third keynote session. Continuing today's theme of science and innovation, our next presentation highlights the growing role of artificial intelligence in understanding the marine environment and supporting ocean sustainability. With rapid progress in computer vision and large-scale learning systems, new opportunities are emerging to observe, map, and interpret the underwater world in ways that were not possible before. We are honored to welcome Professor Saifid Lim from the Hong Kong University of Science and Technology, where he serves in the Division of Integrated System and Design, as well as Department of Computer Science and Engineering and Ocean Science. His research spans computer vision, computer graphics, 3D reconstruction, computational design, and marine AI, with contribution published in leading international venues. His work breeds cutting-edge AI with practical marine applications, including underwater imaging, biodiversity monitoring, and 3D seafloor analysis, reflecting a strong commitment to integrating advanced computational tools into real-world ocean challenges. Please join me in welcoming Professor Saifid Lim to deliver his keynote presentation.
Hello. Hello, can you hear me? Can you hear me okay?
Yes, I can hear. We can hear
Okay.
you.
Oh, thank you so much for the introduction. Yeah, really my honor to give a talk today. Let me first share my screen. Yeah, hello everyone. In Bali, at Udayana, and also online. Yeah. Good morning. Okay, so you already introduced me. Let's see if the slide's going okay. Like I'm sharing about myself. Yeah, just want to see the slides. Okay, yeah. So yeah, I'm a faculty at HKUST, ISD, CSE, OCS, RI, and I think yeah, Mehdi already introduced me. Want to say a bit more. So I'm an ocean lover. So I like surfing, scuba diving. That's why I always visit Bali, and also like now putting all my research effort on the marine related topics. And today's we are going to talk about like AI and systems design for marine challenges. And I will first begin with AI. Okay. So what AI we are trying to do? Okay. So yeah, I'm more on the visual understanding. So these days you can take a lot of videos for the underwater environment much easier than before. So you can use a robot or let a GoPro doing your diving, fly a drone over the sea surface, or you can put a 360 camera like BRAF into the ocean. So what can we do with that? So basically what we are doing on marine AI is on visual understanding. Basically want to do 3D scene understanding that include geometry, like 3D reconstruction, simultaneous localization and mapping like SLAM, that's for robotics, And also semantics like object detection, recognition, like tracking, or object counting, that is very important. And also like semantic segmentation that I'm going to show you more. And also some other latest AI topics like vision language model, VLM, or content generation. And other topics like image video enhancements, I'm also going to show a bit. Yeah, so in Hong Kong, yeah, we also partner with WWF HK. So what they do is they like send a robot doing their bullshit. You can see like on the transit line, we collect the videos, and then we can do something like this, which is photogrammetry. And I hear the earlier speakers also talk about that. Okay, so with the photogrammetry, you can get a better understanding of the 3D environment of the seabed. Okay, and we also put the result online as a WebGL 3D model. But what more important besides photogrammetry, 3D mapping, is we need to understand what are the objects or creatures, or what are the things that are on the seabed. Okay, and then we need to do AI on that. So there's a different challenges for us to apply AI algorithm or computer vision algorithm in the marine environment. For example, like dynamic objects, dynamic lighting, or low visibility. Sometimes you get camouflage objects that will confuse the AI, and also color attenuation. And more importantly, since the modern AI nowadays really like data-driven approach, we require a lot of data. So not enough data is one of the main challenge for the marine AI to develop. But I would say in the past few years, like my group, or I can see other groups like in the community have been working very hard to make more data available so that we can develop new models. And I'm also going to show you some of the latest models that we developed. But before that, I want to like share a bit of the strategy I like get into this marine AI research topic. So first, perhaps it apply to any other research direction. So I start with an easier problem. So I try to do SLAM instead of semantic 3D reconstruction. So when I say easy here, I would more referring to the problem itself doesn't require a lot of data. Okay, so we can still use some the first computer vision principle to estimate the solution without a large amount of data. And then of course, if you don't have data, then we build new data sets and also build tools that facilitate us to build new data sets. And finally, those data sets can be used for benchmarking or as AI foundation models. Yeah, so SLAM, what is SLAM? Simultaneous localization mapping. Basically, is you want to get you see here the path of the camera or the robot moving around, and also the 3D, like the environment around you. So this is one of like early approach I try on one of the diving video I have, and I submitted as a preliminary result for like research one. And then yeah, we basically want to work out a more robust SLAM solution for perhaps like marine robot navigation or other study. So after a couple of years, so now we can get something much better than before, like real-time photorealistic 3D mapping. At the same time, can get the trajectory of the camera movement. And now we can also do a much longer trajectory than before. So this is related to a problem called visual odometry to estimate the camera pose and like basically the track of the camera. So we can have a long range like this camera motion. And we also build different data set. So this data set actually a collaboration with the NGO in Nusa Penida in the Ocean Project. And so this is a new data set on comprehending a marine object, marine image. And beside image level, we also have an object level annotation. So previously, all these data set are on the image level. So yeah, we can let like different images, and then we have the student intern there to do captions, big bounding box, etc. And yeah, compared with earlier data set, so we have a much longer like textual description, and also this is object based but not image based. That is related to some of the foundation model I'm going to show you later. And for example, like if you can do the object detection, then yeah, for example, you can detect the ghost gear, ghost net, other things in real time, so you can do some planning to retrieve it. And it's also important in the future if you want to have an underwater robot to do some autonomous operation. And if we add object detection and SLAM together, there's something called semantic SLAM. So basically, on the 3D environment, you could have like the object 3D location in the 3D map. So this is some prelim result that we're trying to push. We also have a research project on that. So you can see on the object detection on the video, we put it back on the 3D map to show where are those objects. And this is, yeah, with another research project, new sea floor surveying techniques. So you can use underwater drone and locate where object recognition is basically semantic SLAM. Okay, so yeah, I did a very quick introduction of some of the marine AI work that we have been doing, like semantic SLAM, object detection, and collect new data. And now I want to introduce like what the current AI community is all talking about, like developing new foundation models. In particular, here we develop a foundation models for the marine image analysis. So the first one will be on coral image dense segmentation. We call it coral scope. Yeah, coral reef important for many reasons that I probably don't go into details. But what I want to show more is, so previously, or basically so far, I think perhaps from like 2004 around there. So so there's a very nice tool called CoralNet published in the market, and marine biologists have been using that to do some visual understanding. For example, give you an image, I will try to understand where are the corals on this image. So you can see CoralNet. It will give you some random point, and then the user can select the type of the coral there, or what kind of organism are there. Okay, this is a very nice tool, and the marine biologists have been using that for many years. But yeah, although CoralNet is very nice, but at the end of the day, there's something we call sparse points analysis. So you can see, give an image, you like this, you probably will have a missing coral, underestimated coral coverage, and inaccurate boundary of the coral. Because at the end of the day, this is something that you get from CoralNet, a very sparse information that you retrieve from the original image. And what we want to do here is, riding on the latest AI development, give you an image. We would like to tell whether this particular pixel belongs to a coral. So it's like a coral image dense segmentation. So every pixel want to know if this is a coral, and we want to do it automatically. So to this end, we develop a new, we call it basically the first foundation model for automatic dense segmentation of coral reefs. We call it Coral Scope. Segment any coral image on this planet. So to do this, we collect a lot of data, like 40,000 images, and then label more than 330,000 segmentation masks. And with that, we have something called very strong zero sort feasibility, and also flexible to different downstream tasks, which is the criteria to act as a foundation model. Yes, a little bit technical. So our model, based on another very nice model called Segment Anything from Actor. Here we do some technical invention. We introduce some new network architecture that let us do like a growth form segmentation. Previously, SAM can just do yes or no, but here we can do the segmentation in different class and also support language input. So I won't go to too much technical details. This is a technical invention we do on SAM besides collecting a coral image data set. And with coral scope, so even the visibility is not good, we can still segment the coral reasonably well. And compared with the baseline method SAM, we achieve much better result. And this is expected, and it is also kind of fair because SAM is supposed to segment anything. So we segment the fish, segment the text, but here in particular, we just want to segment the coral. And we also get a strong zero-shot generalization ability, which means in the training set, even we don't have the coral images from particular area where we never been to there. For example, like here we have some deep sea coral, but we can still segment them reasonably well. And for different downstream tasks, you can see if we use CoralNet, we can have a sparse point output, but we can take CoralNet output as our input and then generate dense mass similar to the ground truth. And also we can do user-defined tuning, so we can also support growth form segmentation. And also like mass referring segmentation, you can see if you give an input image and then the referring mass, and then we can segment the corresponding coral, like the mass indicated. You can see at the bottom, if we don't have this reference mass, we can segment all the corals automatically. But if we give the system the reference mass of a particular type of coral, then we will just segment that type of coral. Similar for instruction following. Like user can give text. For example, like the user to segment the apple cover coral, then you can see at the top, we just segment the coral at the back. So with this, we can apply this coral scope to 3D coral understanding and also improve the bridge coral analysis. And now we're extending to video, coral video segmentation. Okay. And we can do growth form, like some semantic coral segmentation. I try to fast forward a bit. And then we can estimate the coral coverage from a video. So it can let us like do a large scale monitoring much more efficiently. And so we also like get selected to some event last year, which is in the Dubai Future Foundation. And we also collaborate with KCRI, like in CAUS in Saudi Arabia. They have a very big, in fact, it should be the largest coral restoration project today. They have a 100-hectare site and plan to plant 2 million coral fragments by 2030. And their project requires a lot of automation, for example, digital twin and monitoring, and also how to support their pilot nursery. And I also did some snorkeling there to check their nursery. And now we need to apply like coral segmentation in their project. So we also create a labeling tool, which is available online. So if you have a mobile phone, you can also take a picture of this QR code. It's ready for download. It's an offline tool, so you can install on your computer. So this is a labeling tool. So compared with, you can see previously CoralNet or the other word called CPC, those are involve a lot of manual effort. But with our coral scope, like NET, the tool, we can do automatic coral segmentation and also interactive refinement. So user can do refinement after the automatic coral segmentation. And then we also have some statistic report for you to start. Okay, so I just talked about the coral foundation model. Now I want to very quickly talk about the general marine image. Okay, I still have like 3 to 4 minutes. Let's see how maybe a little bit over. Okay, so I just want to ask, like, if I want you to understand this marine image, how would you do it? Or like these days, you probably will try to ask the VLM, ask the AI, ask ChatGPT, okay, or ask Google. Okay, tell me about this image. So we apply one of the latest VLM tool. This is the answer. This image appears to show a group of colorful fish swimming in the water, which I won't say this is wrong, but I think this is something that you hope more from the VLM. Okay. But so far, the VLM, they are good in doing image level scene understanding. So how about apply segment anything? If you apply segment anything, you just get a lot of segment, and some segment may not have any meaning because they're semantic agnostic, so no semantic key. So what we need to do here is we need to define some basic tasks for a marine image analysis model. And in this work, we propose something called instant segmentation. So we segment some instant object that is meaningful. And this will be useful like after we discuss with the marine biologists for object counting, object detection, or even more advanced like species identification, behavior understanding, and so on. Because we know image level scene understanding cannot satisfy the domain requirement. Okay, so we propose like this segmentation plus the open-ended instance captioning. So now what we do is called regional instance understanding. So if you click the object, then you can, oh, the mass is a tropical fish with a long, colorful tail and a blue, yellow, black body. Okay, so instance caption with semantic richness from also multiple granularities. So now we can, for example, click this object, then we say, oh, like this is a blue fish with yellow fins. Or click this cover, then we have a better description per instant object. Yeah, so with this, we developed this foundation model for marine image analysis, we call marine ins, which is powered by this marine ins 20M dataset. This is the largest marine image dataset today. So we collect like almost 2.5 million images and then create almost 20 million instant masks. Yeah, we have some like manual labeled masks initially, and then the model will keep iteratively generate more semantic and like the instant mask. And with this, give an image, you can click and we can generate description. Like, and you can click on different marine objects and we can generate description that is meaningful to describe among those objects. Okay, yeah, I probably like use few more minutes to fly through some of the work. So for example, like we're also doing on 360 object tracking, because compared with the normal image, normal perspective image, 360 object tracking is more beneficial for the marine environment. Yeah, we also want segmentation, just get published this year. 360 segmentation, I try to fast forward a bit. And also like image or video enhancement for SLAM. And if you do all this together, this basically the whole framework, improve the videos and then do object recognition and SLAM and everything put together. And we also work on a like VR application, yeah, plus some of the VLM we have, Marine GPT. Yeah, basically this is yeah, this is more like education tool. So user can go into the ocean environment and then interact with the object, and then we can generate a description for the object. Yeah. We have 4 environments: deep sea and mud flat. Yeah, so this is the so this is VR application. And finally, yeah, like minutes on this system design for marine challenges. It's very interesting. Like you can put in a fish tank, then you can do 24/7, 360 monitoring, and then we can also apply AI algorithm to some event detection. And finally, we are now having a project right beside our school campus. I create sustainable smart marine grid. So I want to make a grid, and within this grid, we will have something like a autonomous, like your floor cleaning robot, but we clean the sea floor. So basically, this is like the concept video with a surface platform, and then we have an underwater robot that will pick the trash. You see here, with computer vision algorithm that's showing here some real-time object detection. Yeah, it's quite a challenging project. I would say it's actually on the mechanical part, not really on the AI part. Okay, so what we are trying is we try to use the blue boat to tow this blue ROV. And it's actually not very easy because now we're having more sensors getting heavy. So we are exploring different options. And also, we're also developing different grippers to grip the objects. Yeah, this is still an ongoing project. It's a very interesting. I would say if we can make it stable and scale up. Okay, yeah. This is like our HKUST campus, so we are doing like a research outside of here. Okay. Okay. Thank you.
Okay, thank you, Professor Samuel, for your presentation. This goes right into the future here. Okay, now we'll open the discussion sessions. Maybe one questions from the audience.
Am I still sharing?
Okay, we have one question here.
Thank you. My name is Andreas Sumiri. Thank you for the presentation, Prof. Said. And it's very interesting topic, and I think we will, yeah, what you have to say is like the end of the future. So we don't really need the diver maybe, so we can just drop in the like robot and then analyze the data. I have a question. Could you tell us or elaborate about the error percentage from this method? So when we generate the data, how percentage or how percentage we can use the result? And did you also do the ground check for the data? Because sometimes there's an error also. And since this for the research purpose, is it AI will be free tools for all the researcher, especially for the student? Because most of AI, a lot of AI actually, but we have to buy. Sometimes it's very hard, like us in Indonesia. And actually, my last question is how we can use this AI, because like me in Indonesia, we have BRAF video that it's so many hours to analyze, and I think if this tool can use, I think it would be a good opportunity. And also there's ARMS, autonomous reef monitoring structure. It's like a settlement plate that we put underwater for 3 years. With so many organisms that living on that plate. So I think this is opportunity. We can use this AI to analyze. Thank you.
Thank you. Yeah. Yeah. I try to catch the questions. Yeah. Not sure if exactly I can hear all. I think one of the question you asked is about the accessibility and usability, and this is a really good question. I want to share this slide again. In fact, can you still see the slide, like the Coral Scope net? So you see at the beginning, we published a technical paper in like, so this is in the ecological informatics, right? I think I'm still sharing. So at the beginning, we published a paper to, let's say, this is a CVPL, is a top conference in our in our community. In fact, I think this is the in the past few years is ranked the best computer science conference in the world, like CVPL 2024, computer vision and pattern recognition. We see that there's a big gap, I would say, in terms of develop the technology and make it really being used by the user. So we have this technical paper, and we also make an online portal at the beginning. But since we are not like Amazon or Google, so we cannot offer a lot of GPU for people to use. So basically, I think there's not many people use that, I would say, in the community. We receive email from some of the US agency like NOAA. I think there's an engineer asked us like to share the code or something. But this, in terms of the usage, this is much less than we hope for. So that's why we found the online portal may not be good enough, and then now we go back to develop this offline tool. Okay, we hopefully more people to use it. But we found that if we have an offline tool, there's another problem because this offline tool you need to download and install or something. So we do provide README files, but again, I think if you are not technical background, they also have some obstacle. We already improved the, let's say you can see at the right hand side, like compared with the original UI, we try to hire some UI designer to design the UI. But still, I would say to make it useful, still need a lot of how to say, for example, I myself, my team, to talk with the biologists. So now we are thinking maybe we also make it an online tool again. But then GPU resources will be an issue because for this kind of more like advanced AI tool, it consumes GPU. So what's the model to make it work? We still need to figure out. Yeah, this is something that maybe user at the end need to pay a small token to maintain the server fee. So this is something that we probably will be expecting. Yeah. I kind of forget the questions.
Professor, the other question is about the accuracy of this tool. How much is the error? What?
Sorry,
Okay,
can you repeat?
Professor, the other question is about the accuracy and the error.
I
The error
see a
rate.
text. Let's ask about the best
It's
method
true.
of image, especially for image in the fishery. I would say if you want to do coral segmentation, I think now, I don't know the same free model they just released last week. They also do some coral, but in terms of coral segmentation, I think I would say in the market we have among the best, I would say, the coral segmentation. But as for image recognition, then I would say, you can try our marine ins for sure, image segmentation for marine object. But at the end, if you want to do a very good like result, I feel you still need to collect some local data to do some fine tuning. This is quite typical for AI research. But I would say if you want to just do image segmentation, marine image segmentation, I think you could try our tool, because we at least openly public in the market, we don't see other like data set that like what we released, because we just released like 2 weeks ago some data set for evaluation. So you could certainly try. I think there's also some specific data set for fish itself. You could also test it out. But I'm not sure if they do segmentation. They may only do object recognition. But segmentation is something more.
Okay, Professor. We have I think one more question in the Zoom chat. The question is, I would like to ask about the best method for image.
That's actually I was actually answering this one, like image segmentation for coral or for marine. Can try ours. Maybe I missed the earlier question. I was actually answering this one, like the one on the Zoom.
I think continues from this question, we need kind of programming skill in order to download and use this AI tool in our computer here.
Yeah. Okay. Yeah. Yeah, and not so easy to hear the question you have. If you have someone can help you to tap, will be the best. But you can like repeat also. Yeah. Yeah, I think the echo sometimes is
Oh, there's technical problem. Hello, Professor.
yes.
Okay, Professor. I think we have to move to the next schedule.
Okay.
Time
Okay.
here. Maybe
Sure.
we can contact you.
I can
So
stop the
now.
Thank you so much. Yeah, but offline, I think we can discuss more. Yeah, I'm very happy to like if there are any other questions and discussion. Yeah, feel free to I hope more collaboration with like Bali or Indonesia like in general. Yeah, I love to visit Bali. Yeah, I want to go, but I have a class later.
Okay, Professor. So thank you once again. Thank you for your presentation.
Thank you.
I hope,
Bye.
I hope to see you again in Bali next time. Okay, ladies and gentlemen, let's conclude our keynote session. On behalf of the organizing committee, I would like to express our sincere appreciation to all our keynote speakers for sharing their expertise. And we are sorry we had a lot of technical problem and delay. So thank you for your attention and participation through this session. We wish you a pleasant continuation of this conference. Thank you.
Okay, ladies and gentlemen, that's all the insightful presentation from all the keynote session one. And thank you for amazing moderator that lead this keynote session one. So we will move to photo session. And that the first keynote speakers, Professor Josaphat, Dr. Hendiarti, and Professor Young is still on the online group. For Professor Josaphat, are you still in the room? Maybe Dr. Hendiarti, are you still in the room? No. Okay, so to Professor Josaphat, are you still in the room? Maybe you can turn on your camera because we will move to next session is photo session. Okay, so
Yeah, I'm here.
So maybe to Professor Sekit Young, are you still in the room?
Yeah.
Okay, nice to hear that. So we will move to photo session. Maybe you can prepare yourself. And for the participant, maybe you can turn your camera. So we can start the photo session. The committee, are you ready? Okay. So the certificate is ready on the screen. Mister, I will count in 3, 2, 1. Once again, 3, 2, 1. Okay, thank you so much, Professor, for amazing and insightful material presentation for today. All right, ladies and gentlemen. So, for the next session is invited speech part 1. And before we move to the next event, I will inform you that if you want to drink some water, the water is ready on the beside door from this room. So if you bring the tumbler or the committee already give you the tumbler, maybe you can use that tumbler to drink. Thank you. So, ladies and gentlemen, we are honored to come back again in ICMFS 2025. We invite everyone to give their full attention as we proceed now for Invited Speaker Session 1, Part 1. So our first invited speaker will be delivered by Dr. Manuela Capello from French National Research Institute for Sustainable Development on site, and Professor Iwayan Gede Astawakarang from Faculty of Marine Science and Fisheries, Udayana University, joining online. And followed by a hybrid panel discussion moderated by Inyoman Giri Putra SPD MSI, where both on-site and virtual panelists may interact. So, without further ado, please welcome Inyoman Giri Putra SPD MSI. Time is yours.
Good morning, distinguished guests, colleagues, and all the participants. So welcome to the third session of this international seminar. My name is Giri. So I have the honor of moderating this session, and we are privileged to have with us two distinguished scientists who have made significant contribution to marine research and also the fisheries management. And our first speaker is Dr. Manuela Capello. She is a researcher from French National Research Institute for Sustainable Development. And now she is also a visiting scientist at Badan Riset dan Inovasi Nasional or BRIN. And her research is mainly focused on tuna fisheries, the fish aggregating devices, or in Bahasa we call it rumpon, and also modeling. So without further ado, please welcome Dr. Manuela Capello.
Thank you. Thank you very much. Just waiting for the PowerPoint. Yes. Otherwise, I'm connected on Zoom. I can share if you want.
Okay, we can share it.
Okay, so
Hello, everyone. Thank you very much, the organizing committee for inviting me as the speaker here. I'm really honored to start this conference. And so, my talk, I think online is not full screen. I have the online on Zoom, it's not. So I hope you can see online and offline. So thank you very much for inviting me. And my talk is about beyond fishing tools, FATS as observatories of pelagic ecosystems. And this is a joint research project that we are conducting here in Indonesia and also in another country in the Indian Ocean, in the Maldives, in collaboration with scientists from BRIN and also scientists from Marte. So you have all the names of my co-authors appearing here, including both Indonesian and French scientists. Next slide, please. So, type of my talk. So first, I will introduce pelagic ecosystems and biodiversity, and then I will explain, even if I think most of you know already what FATS are, and also why we use FATS to monitor pelagic biodiversity. I will also introduce the concept of how we monitor pelagic biodiversity in FATS, and I will provide you some preliminary results of the studies that we conducted here in the north of Bali, and I will end up with some perspectives in terms of collaboration, in particular with Udayana University. Next slide. So first of all, what are pelagic systems and what are the species that we want to address? Pelagic species that occupy the water column that are not closely associated neither with the sea bottom, neither with the shore. And in particular, we work on epipelagic species, which are species that occupy the water up to 200 meters depth. Next slide. So the reason why we study pelagic systems is that because they are important for a number of reasons. They are large, they occupy more than 70% of the Earth's surface, and we had previous talks about blue carbon. So they are important also in these terms because they have a key role in carbon sequestration. They are important for food security because 80% of the food, which is the fish that is consumed, comes from pelagic ecosystems, and they are important for livelihoods because the pelagic fish is very important, in particular for fisheries. Next slide. So I'm here also as a tuna expert. This is another domain I'm also working on. So tuna are pelagic species, and in particular, the tropical tuna correspond to around 5 million tons of catches yearly in a global scale. So we have three main species, yellowfin, skipjack, and big tuna. You can see in this graph the evolution of the catches. And so they are very important species that we also want to monitor this kind of approaches. So why do we want to monitor pelagic species? Because they are subject to many threats, fishing, but also marine pollution that was discussed in one of the previous talks, and climate change. And currently there are several gaps of knowledge on the species occurrence and abundance. At the same time, we also want to monitor the biodiversity. And why we need to monitor biodiversity? Because a diverse ecosystem is more resilient to all the kind of stressors that I mentioned before. And when we look at the status of pelagic ecosystems and pelagic species, for example, for pelagic sharks and rays, we have that around 1/4 of the sharks and ray species in the pelagic environment are data deficient, and 1/3 of those that have been accessed have been considered as endangered or vulnerable. Sorry, next slide. Next slide. And then next slide. So regarding the tuna species, we also have that among the 3 main tropical tuna species, 2 of them, the yellowfin tuna and the bigger tuna, have been considered as overfished and subject to overfishing in the Indian Ocean and Turkey. And the majority of the teleos fish species are currently unassessed. So the main focus is on the commercial species, but majority of these species that are not very important commercially, we have no idea of their status. Next slide, please. Regarding the cetaceans, also the situation is a little bit better, but when we look at the open ocean species, there is a larger portion of the cetaceans that are also data deficient. So there is an overall need to improve our knowledge on the status of these species. Next slide. So why do we have this lack of knowledge? Why most of the pelagic species are data deficient? Because pelagic species are remote and they are difficult to access. They are sparse and also they distribute patchily. So it's a big challenge first to access the pelagic environment and then to find the species that we want to observe. Next slide. So at the same time, the same challenges are taken by the fishers, right? The fishers also have similar challenges as us. And they found out a way to access the open ocean and the species, some of the species that occupy the open ocean. They build fish aggregating devices or traps. So in Indonesia, and so they are dogs or buoys that are constructed by the fishers to attract the pelagic fish species. And currently, 30% of the catches of tropical tuna fish are conducted using fish aggregating devices. And in Indonesia, pads are widely used by the tuna fishers. Next slide. So why do the fishers use the pads? Because several pelagic species have this associative behavior. So they can spend several days, but even several weeks or several months. This has been documented using electronic tagging nearby the same floating object. Next slide. So the fishers understood this behavior and they did that. Why? Because the pads increase the accessibility of the fish, and the fish then has higher chances, next slide, to finding the fish and catching them. So the concept of our project that we started to develop here in Indonesia is that pads can increase the accessibility of pelagic fish species, not only to the fishers, but also to accessibilities. And so the idea of the project that we run, which is called MOVI, the EU Fund project, is to use the pads as privileged platforms for monitoring the biodiversity of the open ocean. And so how do we do that? Next slide. We deploy a number of technologies, which include the video. So we had a nice presentation before about the video. So the idea with the video is to monitor during the daytime, and in particular the species that are closely associated with that. Then we have the bioacoustic, so we can monitor the species, the ecosounder to monitor the presence of tuna, the DNA using metabarcoding to detect species that are nearby fat, and also the fisher's knowledge. So this is done in collaboration with different experts in the field, and in particular the fisher's knowledge done also using a transdisciplinary approach that involves social science. Next slide, please. So the movie module, the monitoring tool that I described, have been deployed already in 3 different sites. We've been doing these observations in the North Valley near Udayana. We've been working also in East Java, in Panche, and also in the Maldives. Next slide. So this is how the module that we deployed would apply. So there is the FAD, which has been held therapon. They attach to the FAD a line with floats. The first component, the video. Then we have the bioacoustics with hydrophones, and then we have the ecosounder module and the DNA. So next slide. For the video and for the bioacoustic module, I'm not going to spend a lot of time because we have 2 presentations tomorrow by my teaching student, Etiatati and Andrewansa. So I'm going to just talk about the other techniques. Next slide. So the ecosounder, the assess the presence of tuna using and we have here an example of the data that we use. So we use a commercial ecosounder convoy, which is called MPI class. The data, okay, thank you. My voice is a little bit low. So the data appears in the color pixels, and so the intensity of the signal can be translated in colors. And using this data, we have already used this data several times, in particular on drifting flats. So this allows to assess the presence of tuna at a particular depth and also at a particular time of the day. Next slide. Similar with DNA, so the objective of DNA is to recognize species using the trapped DNA particles transported in the water column. So we use 2 different approaches. One is using filters that can capture DNA with a collection of samples with buckets. And then the second is a passive DNA approach that uses metaprops. So next slide. This is just an example of the results that we obtained in the North Valley using the 2 approaches, the filters and the passive DNA. So what we got was first to compare these 2 approaches, and what we find is a good overlap between the passive and the active DNA. So in total, we could assess at the species level 39 species, and the common operational taxonomic units between the passive and the active DNA were around 35. So this first study can demonstrate that both approaches are kind of have a good overlap. Next slide. So this is to conclude. So the main take-home message and effective. So our approach relies on the idea of using facts as monitoring platforms and a variety of techniques to monitor pelagical diversity. The first results show that we can use these complementary tools effectively to monitor the species that associate nearby paths. There are, of course, many perspectives of this work. The first is to build composite indicators. So we can detect the different species with different approaches. Now the idea is how do we combine the species detected with the approach together to build composite biodiversity indicators. Also, another perspective is to combine the data that we collect with these approaches with remote sensing data. And here we have discussion with the University of Udayana about potential collaboration on this topic. And of course, the idea now is to use this tool in applied research, monitor and support management decisions, for example, when developing marine protected areas or during assisting fisheries management decisions with this new monitoring. So thank you very much and sorry for my voice. Thank you.
So thank you, Dr. Manuela, for your interesting talk. So Dr. Manuela has already mentioned that the FATS, or we call it RUMPON, has a very significant role for monitoring the biodiversity, especially for large pelagic fish. So now we have some time for the questions. So feel free to raise your hand or write your question in the chat. So anyone want to ask Dr. Manuela? Anyone? We still have maybe 10 minutes for this discussion session. Yes, Pak Pandi.
So thank you very much, Dr. Manuela, for your excellent presentation. One thing come up in my mind is while using the eDNA compared to the facts. So it is kind of combination, or we need to compare what the advantages and disadvantages between both tools that we use to monitoring the biodiversity. Thank you very much.
Thank you very much. Thank you very much for the question. So indeed, every monitoring technique has its advantages and drawbacks, and there are different spatial coverages, different temporal coverages, and the idea here is really to compare the different methodologies and integrating them, because there is not only one methodology which is good. Each of them, as I said, has different advantages and drawbacks. So regarding the DNA, so your question is more about the DNA. EDNA requiring sample the water, so that distinct monitoring approach. When we go there, we physically go there, we need to take the water samples, and then there is also quite a long delay for processing and analyzing the other cases like on the field or for the bioacoustic technique. Can monitor continuous. So the discrete versus continuous a difference, but at the same time with DNA, as I was showing the preliminary results, we can already monitor quite a lot of species, so it's very important
Another question? Yes. Thank you. It's very interesting presentation. A lot of information. My name is Andreas Smith from Indonesia. I'd like to ask about, did you also collect the data connectivity between those and that's my first question. And also the second is just wondering, did you detect also from the EDNA data, like marine mammal, like or species that also can be used because it's like seesaws, right? So it's very important to get those data, especially to build like marine protected area, those area. Thank you.
So regarding the connectivity, so what in each area we monitor at the same time 3 different paths. For the moment, the project limited in terms of capacity of monitoring multiple paths. So what we are trying to understand for the moment is whether there is a difference in the species composition between paths that are not too far away, but we are not looking at connectivity questions for the moment. And then regarding the marine mammals, we have detected like dolphin sounds using bioacoustics, and definitely this is very important for conservation purposes. It also happens that we collected the same sounds in the Maldives, and we kind of better understand also the use of dolphins of the bats. Actually, they come, especially during the night, it seems to happen, and they feed at the time. And in cancer, regarding important relevant megafauna, we also could observe whale sharks nearby park. So of course, this is important for conservation work. And sharks also, which are endangered, of course, relevant species for conservation. We could observe some pelagic sharks, rate speed sharks, for example, have been monitored with the
one more question? Yeah, one more. Just curious, based on your research right now, do you find where the most abundance, I mean, for the aggregation side? Is it in Bali, it's most abundant? Because everybody say that Bali is like, we have like a lot of tuna here and all this. Is it true based on your result, or do you have a different perspective?
Thank you. This is also another very important question that we have not answered normally. So we were in the north of Bali where they have wolfhounds, and we three facts we cannot really, I think, we cannot really talk about abundance comparisons. This project would require to be much larger, right? Really affect the abundance in the different regions. It's more like for the moment, more like a proof of concept that using these different methodologies, we can monitor different species and use it, for example, for abandoned eggs. For the moment, I cannot really hope to. Thank you.
Yes, I believe there is more question from you, but unfortunately, we have a very limited of time. So we will end this session. So thank you once again, Dr. Manuela Capello, and we can give a big applause to Dr. Manuela.
So for Dr. Capello, please once again, may you please come to the center to take photo session and to hand over the certificates. And we welcome to the Dean of the Faculty Marine Science and Fisheries to hand over the certificates. So please give round of applause to Dr. Capello for amazing presentation. So for the next event, I will give time to moderator. Time is yours.
Thank you, DMT. So our next speaker is Professor Eric Gilson. He is from the University for the Azure, and he is internationally recognized for his pioneering research on telomere and their connection to the cancer and aging. So Professor Eric Gilson will join us in Zoom. Hello, Professor Eric.
Yeah,
Can
do you hear me?
Yes, loud and clear, Professor.
Okay, I share my screen.
Yes, please.
Is that okay like that? Do you see the screen?
Yes, we can see, but you should.
Okay, perfect.
Okay.
So first, of course, good morning, everyone. And of course, I'm very sorry not to be with you here in Bali, but I would like to warmly thank all the organizers and Professor Geden Drawan for this very kind and interesting invitation. Anyway, so the topic, the main topic of the talk is aging. So maybe it seems to be maybe a little bit far from the other interventions, the theme of the meeting, but I hope I will convince you that it's not completely the case. And the link between aging of coral, reef coral, and the thermal effect. So next slide. So it's really a very a general introduction for you about the biological mechanism of aging. So as you know, of course, aging is a progressive deterioration of our physiology, but behind that there is a lot of various cellular process and molecular process that are involved. And what is very interesting is that we learn a lot from wild species, because the very intriguing aspect of aging is the fact that the longevity of organism is very diverse and sometimes surprising and sometimes very long. And let's say very grossly, we can divide, let's say, the biosphere in short-lived and long-lived species. But in fact, they're all in common to, let's say, modulate this basic molecular and cellular biology of aging. And of course, the long-lived will somehow behave like a brake to this process by various mechanisms, and the short-lived are more dependent upon the timing. So there are, of course, many things to learn. You may notice, and this is the first link with this meeting, that among the long-lived species, many, not all, but many species are living in the sea, in fact. And there is even others, and I will speak about corals. So the questions we ask, I'm working on aging for a long time. And so some years ago, I was interested to ask the question of aging for coral. Why? Because in fact, it's very interesting to see these various species of, let's say, stony coral that have a very different type of longevity and very grossly, so we can distinguish the short-lived like Pocillopora species and long-lived massive coral like Poraites. And I gave at the bottom of this slide a very nice review on coral aging by Bittel and all, so I encourage you to go there. But except this great diversity of maximal longevity, of course, we consider the colony of coral as an individual and not the polyp by itself. And there is many arguments for that. So in fact, about the mechanism, very, very little is known when I start this study. So we know, and probably you know as well, that there is an increase of partial mortality with age in various colonies. So you have an example. And the short species rather show a determined growth. That means that they have a limit in their growth, which is not the case for the long-lived. The same for reproduction, in fact, and you have an example here of a very old coral that is still able to produce gametes. High frequency of somatic mutation, I would say that it is like in our body. And also regarding the resistance to stress, which will be, let's say, the main angles that I will show you. I mean, we don't have to forget that the bleaching event in response to various types of stress, as you know, in coral, is a physiological process, and which can be, and I think something that has to be studied in more details, linked to aging. I mean, you may know that caloric restrictions is a way to live longer. So the fact, I think, very intriguing that the coral choose these directions of expulsing the microalgae and to be under caloric restriction, in fact, as a stress response, of course, if the stress does not last too long. Anyway, so this is the basic point why we work on aging. And I think that, as I said, it's very interesting to compare the short and the long-lived species. Moreover, it is even more interesting because these two types of coral species, which have a similar physiology, let's say, basic physiology, in fact, they are living exactly the same site. So that means that we can compare for the same environment, short and long-lived, let's say, relatively closely related species. So this is this comparison that I thought at the beginning would be very interesting. To address that question, I had the chance, I would say, and the opportunity to be part of the Tara Pacific expedition some years ago, 2016-18, throughout all the Pacific with various objectives, but the main one being to characterize, in fact, the complexity of coral species, let's say at a wide scale, at a full ecosystem scale, which is a very great opportunity for various scientific questions, of course, but I was in charge of the telomere and aging studies in this expedition. This is just as a quick reminder. So 32 islands were samples, 3 sites per island, 3 coral species, Millepora, Pocillopora, and Porites. And it's a big consortium of more than 20 labs. And so with all of these samples, so it's largely published now, that we collect a lot and we generate a lot of data from environmental data, including historical data and also omic data, molecular data at a large scale, at all the scale, in fact, of the living organism, from the symbiont to the seawater. So regarding aging, in fact, we have 2 hallmarks of aging that we studied, telomere, which are the tip of our chromosome and that are known to be a key driver of aging in various animals, in fact. And but also oxidative stress, that is some kind the complementary marker of biomarker of aging, but not only a biomarker, but also a driver of aging. And for several colonies of coral, and focusing on these 2 species, the short-lived Pocillopora, long-lived Porites, we measure telomere length, and we measure, let's say, a marker of oxidative stress, including protein carbonylation and the TOSC, that means the total oxidoradical scavenging capacity. And we were able to match, in fact, this variable with all the data that was generated during the expedition. A key point is, of course, to determine the chronological age of this colony, which is not an easy task, and we took a not so good proxy, which is the diameter of the colony. And so we are totally aware that it's not perfect, but it was the only way that for all this colony to have a proxy of chronological age. But in fact, I will summarize the results that we got and that are mostly published now, in fact, 2 years ago, in a series of publications in Nature Review. So regarding telomere length, the first observation, as I said, telomere length decrease with aging, chronological aging in human and various animals. Not all of them, but various animals. But is the case, but relatively with a slight slope, but a faint effect, is the case for the short-lived Pocillopora, but it's not at all the case for Porites. And really, we collect various Porites from various islands, as I said, but also we sample Porites from the same sites, very small colony and very huge one. And there is no change in adult, of course, colony. I don't speak about any possibility of telomere shortening during, let's say, the early development, which is likely to be the case. But when you are adult, you don't lose your telomere, even if you compare very small and very large. And we are sure about the genetic. It's not these Porites are not clonal colonies, because we did the genetic structure of all these colonies. So regarding environment, which was with our models the main effect, and particularly the temperature, but what was very interesting, I think, is that in fact the dependency upon the environment, and particularly the seasonal temperature side. Sorry? Is that okay? Okay, may I continue? Okay. So okay, so I'm hearing voice, but okay. So to go very directly to the point, is that the Pocillopora are much more, I mean the telomere length, at much more dependent upon the seasonal temperature of the site of origin, being longer, let's say, in the warmer environment, like Kimbe, for example, and shorter in a colder environment, like Eastern Island, to give examples, which is much less the case for Porites, the long-lived. And regarding oxidative, hello? Hello, is that okay?
Okay.
Yes, go ahead.
Do you hear me?
I continue the presentation.
I continue. Okay, so we
Yes,
have
please.
to summarize, we have exactly the same effect. Comparing Pocillopora and Poraites regarding oxidative stress, which means that, in fact, for Poraites, it's much more, let's say, the expression of the oxidative defense or the presence of oxidized protein is really similar all along the Pacific, throughout the 32 islands, which much more diverse according to their environment for Pocillopora species. And you can see both by PCA and this SPLS statistical analysis modeling. So the main conclusion of these two parallel work is that there is a string difference for these two aging biomarkers between short-lived and long-lived regarding environment. The short-lived, the stress-sensitive Pocillopora,
Dia sesuai dengan
have telomere that varies with.
bila writing kan gitu. Nah kalau writing.
Sorry, Professor, we have some issue here. Our team will try
I'm
to
sorry.
solve the
I'm
issue.
sorry. I don't hear you. You try to say something, but. So, what happened?
Yes,
No?
Professor, you might continue your presentation. I'm sorry for the issue.
I'm sorry. I don't hear what you want to say. So the conclusion is that these studies show that coral reef are a new model and interesting model to study the link between environment and the aging process, comparing the short and the long-lived species. All this very huge morphomolecular data set of the Tara-Pacific is an interesting baseline for further study of reef coral aging. And very interestingly, age is not, I mean, chronological age is not for the long-lived, but only slightly for the short-lived, a factor that contribute to telomere shortening. And telomere length and oxidative stress are mostly determined by seasonal in short-lived, but not in the long-lived. So, which in fact rise, which is the ongoing thing that we are studying now. I think two very important questions is now our coral aging, and which of course can be a way of for the coral health, of course, is regulated by temperature. So and also, I think that this raises some kind of new concept that chronological age is not necessarily the best determinant for aging, but is what I like to call the environmental aging. Is very important as well, and I think that this really what we start to learn and to understand from reef coral. But I would like to say two other things, and I think that I'm very happy, somehow different, but maybe not so much. Starting collaboration that I have with the Udayana University, and I would like to mention that at the end. Is something ongoing, so I don't show real data, but I would like to share with you what we are starting to do, in fact, with Professor Rawan. And it's a way to measure coral health. Of course, we have in mind that maybe it can be linked to the aging of those colonies, but in a more general sense, really to try to revisit what we call coral health, that in fact is, from what I see in the literature and in practice, relatively vague, somehow concept. And so in order to do that, we are developing, in fact, an AI approach to really catch in each single colony of given species a hallmark of health. We define 9 hallmarks like predation, pigmentations, and color, and so on. So we define 9 ones which are enough in fact, to define not only the health state of this colony, but of a full site by taking photography of 3 species of coral, Acropora, Pocillopora, and Porites, on 3 transect of 20 meters. It's enough. And since it is an AI analysis of very simple photos that you can take during diving in a very easy and very simple manner, it is a non-invasive protocol, of course. And we can define index, so it's really the ongoing things we are doing now, of the what we could call the coral reef health state. So this is something that we are starting with Professor Awan.
Sorry, Professor, to interrupt your presentation. I kindly
I
remind
have
you that.
difficulty, sorry, but I have very difficulty to listen to you. And so if you want to know more, and I will finish with that, I invite you for the kickoff meeting of this project, Coral, which will be in Sanur, here in Balui, the 22 of January. So like that, we will be in person, and it will be easier to discuss if you are interested by that. I strongly encourage you to come if it is the case. So I would like to thank, of course, my team and so on. Sorry if I did not catch exactly what you wanted to tell me. Okay.
Thank you, Professor Gilson, for your interesting talk. Personally, I never thought before that the coral is getting old. So that is very new for me. So we now to the question session. Anyone who has a question for Prof. Ibu?
Hello, I think Professor
Yeah.
Gilson.
Yeah.
Yeah,
I try to
yes.
listen to you. Okay, please go on.
Yeah. So thank you for the talk. Actually, my question is, what depth you collect your fossil flora and varieties? Yeah. And what's the location? Actually, I know you mentioned.
I'm sorry, but the sound is very, very bad. If you can write your question, it will be easier because really, sincerely, I have difficulty to hear what you said.
Sorry, Professor. May I ask some question?
Yeah. Please go on. I'm hearing you well. And before, it was not the case.
Okay. Let me introduce myself. My name is Nyoman Arya from Department of Marine Science, Udayana University. So I'd like to ask you a question. Now I'm currently drafting my thesis on the recovery of coral affected by thermal stress in XC2. So I'm considering for administering dosage of parameter like calcium, sodium, phosphate, alkalinity, and some similar parameter. So my question is it possible to administer this treatment to recovery coral affected by thermal stress? And will such treatment cause further stress or accelerated aging? That's my question. Thank you.
Okay. Thank you for your question. So my answer, of course, I don't know for your specific treatment, but I would say that now for this type of study of stress resistance of coral and some interventions to mitigate that, I think that the parameter of, let's say, coral aging should be taken. So I think that it's worth to look at telomere. Oxidative stress is obvious. It's already, let's say, done several times, but to have a specific parameter of stress response, it's very interesting, the telomere, because it is, let's say, a biomarker of stress and contributing to aging, but that remains with time. That means that if you were stressed a long time ago, if you are a coral colony, 1, 2, 10 years ago, there is a memory, in fact, of this stress regarding the length of your telomere. So I think that they are not, for example, if you take oxidative stress, you take it only at the time of the sampling. And so I think that any study of that sort that you are doing, if I correctly understood, yes, it's worth to have marker. We can discuss that further, maybe if you are interested by mail or when I will be in Bali next January. With pleasure.
Yeah, thank you, Professor, for your explanation.
Thank you, Professor.
Okay.
So another question on the chat. So the question is from Ibu Widi.
And we, of course, we record the depth of each sampling, and we check whether it was a parameter that could determine viability of telomere. We did not find a correlation, a clear correlation with that, but you know, it's within 5 and 12 meters at most. Okay, that's where we sample.
Thank you, Professor Eric. Is there any question? No? So once again, thank you, Professor
Bye-bye.
Eric.
Thank you. I'm sorry I have to take my
Thank you for
place.
your
Bye.
talk, and see you in another conference. Thank you.
Thank you. Bye-bye. Thank you so much. Have a nice meeting.
So for Professor Gilson, please stay on the Zoom room because the next session is a photo session. So for Professor Gilson, are you still on the room?
Kedua jangan di sini. Yes, Pak Pandit.
So ladies and gentlemen, so please keep in the good condition and please stay on your place because the next event is invited speaker session part 2. So we have our wonderful, amazing invited speakers today who will deliver by Professor Iwayan Gede Astawakara from Faculty of Marine Science and Fisheries, Udayana University. And then we have a second invited speaker today, that is Professor Susan Jobli from Brunel University, and both of them is joining virtually. And then also we have a moderator today, and panel moderator discussion will follow by Dr. Pandey Gede Sasmita Juliantoro, MSI. So without further ado, please welcome Dr. Pandey Gede Sasmita Juliantoro, MSI. The stage is yours.
Thank you. Good afternoon, everyone. It's an honor for me to moderate the fourth session of our International Conference on Marine and Fisheries Science 2025. So we have in this session two distinguished speakers, Professor Astawakara from Udayana University and Professor Susan Jobli from Brunel University. For the first, I would like to say hello to Professor Karang. Is already in the room.
Yes, Pak Pandey. Thank you.
Okay. So Professor Karang is one leading scientist in Universitas Udayana for the remote sensing area and also the modeling of oceanography. So you have 15 minutes of presentation time. So time is yours, Professor Karang, please.
Okay. Thank you, Pak Pandi. Wait a moment, please. I would like to share my my screen.
Ini ada. Mm-mm. Gimana tadi?
This committee.
Ada. Oh ini nih.
Yes, please continue, Dr.
Okay, thank you, Pak Pande, as the moderator. Om Swastiastu. Good morning, or good afternoon, ladies and gentlemen, and also all participants today. Welcome to the first international conference on marine and fishery science here in our home, Udayana University. So already introduced by Pak Pande, my name is Gede Karang. I'm from Department of Marine Sciences, Faculty of Marine Science and Fisheries, Udayana University. So today I'm honored to present our latest research titled Internal Solitary Waves in the Southern Indonesian Trough Flow from Wave-Wave Interaction to a Regional Atlas. Next, please. So my presentation today is will contain in four main parts. So we will begin with the introduction to internal waves, and I will then cover the methodology we use in this study. Then I will present our result. Finally, we'll close with our future work and conclusions. Okay, so first, I would like to explain what is internal wave. Okay, while maybe you all or we are very familiar with surface waves, but the internal waves are different. So these waves are massive, slow-moving waves that travel within the ocean, not on its surface. As this figure shows, so they occur in the pycnoncline layer. So, or we call it as an interface layer. So this layer is interface between low density warm water and high density cold water below the layer. Actually, these waves generated when the strong tidal current flow over the steppe bathymetry like a shield. So one of the sites very famous with this wave generation is the Lombok Strait, and is as a global hotspot for their generation. So the question is why we study these waves? Why do they matter? Because these waves will transport huge amount of energy as they propagate and break. They drive a horizontal current, overturning, and most importantly is intense turbulent mixings. So these mixings is very fundamental for the distributing heat and nutrients throughout the oceans. Okay, next please. So these waves are very important for various aspects in the ocean. This make them incredibly very important because for scientifically they are a key to understanding the tidal energy dissipation and the turbulence in the thermocline layer. So, but they also have a major impact on human activities. So they can put large stresses on offshore oil rigs, affect aero view operation, and are a significant hazard to submarine navigation. We still remember that very tragically, to say accident in 2021. So the sinking of the Indonesian submarine KRI Nanggala 402 in 2021 occurred in the Bali Sea. an area we know is very highly active with these waves. So this has highlighted the urgent practical need to understand and this phenomena in the water. So very famous publication in 2022, I'm sorry, by Wong et al. Also try to model how this accident occur by this wave in the Lombok Strait area. Next, please. So, on the other hand, this wave also influence the transport of the sediment in undersurface. So these figures show the schematic diagram of on the suspended particle matter transport by the internal solitary waves modulation in the ocean. So actually, we can see clearly from this figure that this wave will control vertical transport and horizontal transport that will impact on the undersurface ecosystem, particularly, for example, coral reef and other ecosystem in this, for example, in the near bottom area. Next, please. Okay, so now, so how we can understand this phenomena? Before we apply the remote sensing techniques, so these waves are mainly observed by the very advanced and very expensive instrument to understand the phenomena in the deep ocean. However, since the remote sensing application technique developed by the researchers, so these techniques can to say used to understand this phenomena because this the ability to observe the surface ocean surface roughness change and also the sun glare effect that we can use to capture the internal solitary wave propagation in the surface area. So this figure show how this wave can modulate the surface and impact to the surface roughness in the ocean and can clearly use to understand how this pattern will or signature will can capture by the sensor, both synthetic aperture radar and also optical sensor. Next, please. So we now have many study related to this wave in the Indonesian seas. So, including several of our own results have focuses on these waves. We have used the ALOS pulsar to map this distribution. So, Himawari 8 to track the propagation and Sentinel-2 to understand the characteristic of these waves. So, however, all this research focuses on the generation and propagation from a single source. So these leaves are critical research gap, which this study addresses what happened next. So and what happened when these energetic waves packet from different sources collide in the same area. So as note here, no study have documented this wave-wave interaction in this highly dynamic region, particularly in the southern part of Indonesian through flow area. Okay, next, please. To understand this wave-wave interaction phenomena, so we can look very foundational research such as by Su et al. In 2013. They categorize interaction pattern into three main types, as you can see on the figures. So the first one is the match interaction, a zipper-like merging of waves, and then regular interaction, a stable crossing of waves, which we will see in this study. And then also the interaction without the possessive, the third interaction characteristic. So these interactions are critical because they can result in exceptionally large surface amplitude and also in the some deep turbulent area in the interaction zone for example, in the Indonesian through flow area in the Indonesian seas. Okay, please next. So now we move to the method that we use in this study. So we focus it on the certain part of the Indonesian through flow area. So, or we call it Arlindo in Indonesia, in Bahasa, sorry. So this consists of the Lombok Strait, Flores Sea, Ombay Strait, Banda Sea, South Sea, Sumba Strait, even Arafuru Sea. So we can see from the figure that this blue line is the pattern of the Indonesian through flow that come through from Pacific Ocean to the Indian Ocean. But before they out to the Indian Ocean, they turn and there are some ocean change of the water column structure in the Indonesian Sea, including modified by this internal wave generation. So we can see that clearly in the Lombok Strait area, according to the GABCO, the topography, we can see the Lombok Strait as the very shallow area at the certain part of Lombok Strait. So we call it the seal. So this seal is one of the requirement to generate this internal wave in the ocean. So next, please. So our method is we use the satellite data set here. For the wave-wave interaction, we are luckily can get very beautiful image from the Sentinel-1 SAR or data, and also we'll compare with the optical sensor by the GCOM-C that are provided by the Japanese agency. And for the Atlas data set, we use the Sentinel-1 and 2 mosaic data from 2014 to 2024. We use the simple analysis in this step. We use pre-processing, and then we continue with extraction, and then finally we use a calculation for the each parameter of these waves. Okay, can move to the results, please. Next. So this is our result from the Sentinel-1 SAR observation data. So in this figure, we can see that using the radar image, we can see clearly that and there is the internal wave-wave interaction in the Flores Sea. We can see that there's several packet origin from the Flores Sea and also very huge packet of waves origin from the Lombok Straits. So we can now identify the precise of the area of the collision of this wave in this area. So from this data, we can extract the characteristic of this wave by calculate the real azimuths and also the propagation angle of this wave as shown in this table. So we can now understand where the source and how they will meet between the packet in this image. Next, please. Then from that image, now we can try to figure out what is how many packet and why this what the characteristic of this interaction. So we can see that we try to extract the pattern. So as the center of the image on the center. So then we try to zoom in or zoom out of the each packet. Then we analyze the pattern and calculate the parameter of this interaction. So from this result, we can understand that there is the wave-wave interaction. They form this thing like a woven or a grid-like pattern on the surface. So this pattern is the surface manifestation of a complex series of the X-type interaction. So we propose this type of interaction, and where the non-linear wave cross-stroke the each or the largely undisturbed, creating a grid of intersection crash of each packet. Okay, next, please.
3 minutes remaining of time.
Okay, thank you. So, and this is the result from the optical sensor. So this is just 1 day after the SAR data, the time acquisition. So we very likely can get this sun grain signature that also expose this wave-wave interaction in the Flores Sea that almost they have similar pattern, almost same with the previous image by the synthetic aperture radar data. We also can successfully to create or to extract the wave interaction parameter like the real azimuth and also the propagation angle using the word techniques. Okay, next please. So this is the to say the zoom out of the each packet and interaction from the GCOMC data. So we can use this optical sensor to validate the synthetic aperture radar data. Then we can understand now each packet, the direction and also the source of the interaction. Okay, next please. Because the time, I will quickly. Okay, so please before that slide. Okay, so this is the our phrase or summary of the interaction geometry from the both data set. We can measure the crash angle, the interaction angle, also the wide of cell area as the result of the interaction between both wave from Flores Sea and also from the Lombok Straits. Okay, next please. So then we will try to report you what we have done to our part of our research roadmap on our faculty to try to understand and also to make the internal solitary wave atlas development in this area. So this roadmap consists in 4 phases. We starting in 2019 with the collection of the data set we will publish from various journal, and also current activities. We now try to initiate to create the atlas with the multi-sensor. Now we almost 81% complete. In the phase 3, we will continue this study to quantitative analysis, validation, and finally we hope that we can establish the product, the final atlas dashboard, and also a mitigation model of this disaster from this phenomena. Next, please. So this is our brief introduction of our atlas. So this is our to say a map of the distribution map of the internal wave in the southern part of Indonesian through flow. You can clearly see from the Lombok Strait until Ombay Strait on the Arab Furus Sea, which each image that we represented this area. Okay, next please. So for the next step in the future work, so we will continue with the quantification using the detailed analysis of a wave parameter, and then we try to understand the impact of this internal wave on the productivity and other undersurface ecosystem like the coral reef, particularly in the Lombok Strait, using the ocean color response. And also finally we combine all data from SAR and optical sensor to complete the atlas and establish the mitigation model. Okay, next, so finally, this is the conclusion for our study. So this is the key finding of this latest research. Is first, evidence of grid-like egg types interaction pattern in the Flores Sea, and then interaction between Lombok Strait northward and Flores Sea packet. So also this study confirmed the capability of the multi-sensor SAR and optical detection of this phenomena. So the implication of this finding is the southern part of Indonesian through flow is a critical hotspot for internal wave interaction and mixing, and the ongoing atlas will be a vital resource for understanding regional marine dynamic and supporting marine resource management. I think that's all of our presentation today. So I'm waiting for the question and comment for our research. Thank you.
Okay, thank you, Professor Kudekaran, for the insightful presentation and also clear explain about the internal waves We'll open the discussion session for Professor Karan. If you have any comment or any question for Professor Gede Karan, please raise your hand, or maybe online participant have question. Yes, please. Doctor.
Yes. Can you hear me? Karan?
Yes, yes, very clear. Thank you.
Thank you very much for your presentation. I'm asking a naive question because I'm really not a specialist in the field. I was wondering what is the temporal variability of the waves that you measure? Are they kind of stable in the same regions all the time, or there's some variability in time? Thank you.
Okay, thank you, Dr. Manuela. First of all, I'm very sorry I cannot meet you in person today. So actually, I'm very happy you can come in on site in our conference. The temporal variability of this internal wave is actually this wave is occur following on the internal tidal phenomena. That's mean will following the phase and the characteristic of the tide in each area. So what we have done here, we try to characterize these waves from the surface because we cannot see this wave from our eyes. So because these waves doesn't affect the elevation of the water, elevation of the surface. But this wave is the giants in the undersurface because this wave can transport the material through the huge amplitude from small until large scale amplitude and transport the material until more than 1,000 kilometers. So we can now several study already try to relate these waves to some like including the rumpon, including the coral, and also including the marine debris. So now we have to combine this study with the numerical calculation and in situ data to understand the precise of the temporal variability in undersurface. I think that's I can answer to you. Thank you.
Any further comments? Thank you, Professor Bekaran, for
thank you, Pak Pandey. Thank you.
Because we have limited of time, we will move to the next our invited speaker. Thank you for Professor Pak Bekaran. Let's have big applause. Okay. Now we go to the next invited speaker, Professor Susan Jobli. Could you hear me, Professor Susan?
Yes, I can hear you. Can you hear me?
Yes, loud and clear. So now it's early morning there in London, right?
Very early.
So, yeah. First, I would like to introduce Professor Susan Jobli. She's an interdisciplinary researcher, was trained first as a marine zoologist and then as an eco-toxicologist. She's now a recognized leader of collaborative research and innovation program focusing on planetary health and well-being. She was founder and director of first Research Institute of Environment, Health and Societies of Royal University of London. Then brought together more than 150 researchers from across the university, combining social, health, and environmental sciences with engineering and design to enable novel cross-disciplinary research approach. Recently, she led the Plastic in Societies, Fisheries, a large interdisciplinary, intersectoral, and international partnership that aims to break down silos between academic disciplines, cross boundaries, and remedy plastic pollution, providing evidence-based solution and system change intervention under a circular economy framework. So without further ado, Professor Susan, time is yours to present your talk. Please.
Thank you. Can you see my screen?
It's still on the way, Professor Susan. Still loading. Yes, please.
You can see?
Yes.
Good. So good morning or good afternoon, and thank you for the opportunity to be here.
Professor Susan, can you hear me? Please.
Mangroves, its beaches, are central pollution. Yes, I can hear.
Yes, please continue, Professor.
Your connection. Can you hear me?
Yes, please, Professor.
Okay, can you see my screen still?
No, your screen is gone. So it's
Here now?
Yeah, it's yes, please.
Okay. So I want to share what I've learned through the Pisces program, which is a partnership across Indonesia, the UK, and many institutions. And it's about how marine protection ultimately depends on what happens on land. So across the tropics, our coasts are changing faster than our science can actually track. So in coral reefs, we now find fragments of plastic which are embedded in living tissue. In seagrass meadows, some of the most productive carbon stores on Earth are tracking debris instead of carbon. And mangroves, which should be nurseries for biodiversity, are accumulated up to 10 by waste that was never meant to leave land. And when ecosystems change, people feel it first. Fishers report declining catches and damaged nets. Seaweed farmers lose entire harvests when drifting debris smothers their lines. And tourism economies suffer when coastlines, once symbols of national identity and pride, become repositories for waste. For coastal communities, plastic pollution isn't distant or abstract, it's immediate, it's daily, it affects livelihoods, it affects dignity, It also affects opportunity. There is also a human health story we can no longer ignore. Microplastics and associated chemicals are now detected in seafood, in salt, and in coastal waters. We are beginning to understand that plastic doesn't just enter the ocean, it enters our food chains, our food systems, our bodies, and affects our children's futures. Open burning of waste releases toxic emissions that return to communities through air and soil. And beneath all of this lies something deeper, the erosion of ecosystem services that we depend on for our survival. Mangroves and seagrasses that once buffered coasts from storms and stored carbon are losing their function. Coral reefs that support a quarter of marine life and millions of livelihoods are under stress. Cultural and spiritual connections to the sea are disrupted as coastlines become places of loss rather than life. So the plastic crisis is not a waste problem alone. It's a biodiversity problem, it's a climate problem, it's a health problem, and fundamentally a human problem. And critically, over 80% of this pollution originates on land. We are failing the systems that stand between the land and the sea. These impacts are real and they're growing, and this is why in Indonesia, we in the Pisces programme set out to trace this crisis from its source through communities, rivers, coastlines, and into marine habitats to understand how land-based systems drive marine impacts and how we might prevent them. So faced with the crisis that begins on land but ends in the ocean, we asked a simple question: how do we follow plastic from source to sea and back to people in a way that leads to real solutions? And that was really the starting point of Pisces. So we can see, this is some of Pisces data, that it's a land-driven crisis with very high coastal risk. If you see, all of the red dots on this diagram are focused in and around the coast. There is massive leakage and very low control because greater than 50% of waste remains unmanaged. So what is Pisces? Pisces designed as a waste project as coasts and oceans, with government partners, universities, NGOs, communities, businesses, and the informal sector. Excuse me. Excuse me. We combined environmental science, social science, oceanography, behavioral research, economics, and policy analysis. Secondly, in addition to the partnership, it was a systems project. Studying of the leakage through to the leakage, down through land, to the coast, to the oceans, and to people. Over 4 years, we worked across Indonesia, and there were 4 components of the project. monitoring and modelling, socioeconomic and environmental impacts, behaviour and social drivers, and then policy and systems leverage points. So to follow plastic from source to sea, we built this 4-part workflow. So first, we developed and standardised field methods to survey beaches, backshore zones and mangroves. We mapped debris, documented habitat impacts and identified hotspots of accumulation. We documented impacts on habitats where plastics were entangling roots, smothering seedlings and altering sediment structure. And these methods allowed us to establish baselines and detect hotspots and link patterns of accumulation to specific land-based sources. But plastic is not just a coastal issue, it's a community issue. So second, we looked at socioeconomic and behavioural insights. We spoke to households, fishers, waste pickers, local authorities. We learned how livelihoods, habits, access to services, and social norms and economic pressures drive waste behaviours, including why burning and dumping persist as well as why people buy single-use sachets, which are abundant in waste and litter. We learned how informal recycling networks operate, how burning becomes a last resort, and how coastal livelihoods are already experiencing the consequences of pollution. And these insights made one thing clear, that solutions must be socially realistic, not just technically ideal. And then third, we did system and leakage mapping. We used systems-based analytical tools and stakeholder mapping to trace where plastic escapes the system. Uncollected waste, unmanaged dump sites, drainage channels, river banks. We saw that leakage isn't caused by one failure, but by gaps across the whole system. We saw how gaps in governance and infrastructure and incentives and markets create a pipeline of pollution that flows downstream into marine habitats. The system was not failing in one place, it was failing at multiple links. Because the system is interconnected, developed intervention and decision to support. We developed a toolbox, monitoring protocols, behavioural methods, design-led solutions, living labs, economic models and policy guidance. And together, this workflow allowed us to link environmental impacts, human behaviours, infrastructure gaps, economic drivers and policy barriers into one system. So what did we learn in Indonesia? And I'm just going to give you some highlights here of what we have learned. So on this first slide, we show that waste generation and leakage are far higher than previously estimated. There are large volumes of unmanaged waste leaking into the environment through dumping and burning. And even a small fraction reaching rivers and coasts poses huge risks to marine life. We found 62 million tonnes of municipal solid waste in 2020, which was double the official data at the time. And we used this data to update the official database. And we found that formal collection captures less than half of this waste. And in peri-urban and coastal areas, unmanaged waste is higher. And the reliability of the collection services strongly predicts the burning. The uncollected waste, of course, drives riverine and coastal leakage. We found that plastics made up 16% of waste on average, but up to 33% in some districts. Low-value flexible plastics are a major driver. The highest emissions were correlating with population density and weak services, and Java is the national hotspot. So what else did we learn in Indonesia? So following the modeling, we validated the modeling by developing a litter monitoring technique. First of all, we reviewed what was actually in the literature, and you can see the reference to some of this now is in the published literature if you want to follow it up. We identified 47 studies on macroplastic in Indonesia, and that was 347 studies across 19 provinces. And we found that plastic bags and food packaging and plastic bottles dominate. But as reflected in the global literature, most of the literature we looked at were beach litter surveys. So there were very little surveys, very few papers based on land and in other environments. We also reviewed the global monitoring methods and found that for the wide scale purpose that we wanted to actually apply a methodology, which was across every province of Indonesia, these methods were not focused near the source. And so they were not appropriate for doing what we wanted to do. So we developed a novel rapid litter survey that focused on measuring litter on roads, tracks, paths, and riverbanks, upstream and within communities. We measured plastic pollution over 26,000 kilometers squared, over 21 towns, with 4 teams on 3 occasions around the monsoon period. And we characterized different types of litter to identify them as problematic that would inform the work that we were doing in other work packages. And the evidence supports riverine delivery to the marine zone, with consumption shifts towards consumer plastics and with fishing-based plastic appearing as we approach the marine environment. So what's been littered? Sachets dominate Indonesia's litter, as you can see here. 75 to 80% of the waste we found was flexible plastic, and we found particularly food and beverage-based plastic sachets and small food service items are the most prevalent. And we found largest quantities of these on riverbanks in large illegal dump sites. Hotspots were near food vendors and roadsides. The usage of sachets is linked to affordability and daily purchasing habits, and it has very strong behavioural and economic drivers. Prevention, therefore, must prioritise land-based systems. We also looked at ecosystem impacts, and you can see the reference here to one of our recent papers. And here, what we actually did was combine 3 tools. One tool developed by Udayana University, which was an oceanographic model, which we tested in the Bali Strait, which you can see here between East Java and Bali, Jembrana. And then with that model, we predicted, validated model with drifters, we predicted where plastic would accumulate. We then combined that with a habitat mapping. So we knew what the habitat was like, whether it was coral reef or mangrove or rock or sand. And then we overlaid that with a sensitivity map, sensitivity scale we had created for habitats, marine habitats. So combining those two, we could look at the sensitivity of that habitat to marine plastic pollution. Overlaid with the debris hotspots, we could show that those high debris zones overlapped with key nurseries and coral reefs, therefore intensifying biodiversity and fishery risks, prioritising marine protection zones. And fish and coast protection. Thank you. We also looked at people and behaviour and unmanaged plastics in the coastal environment harm important natural services that support the economy and human well-being. The darker the red boxes are on this map, which you can find in the paper, the greater the negative impacts are. And these are characterized by habitat, but you can see the ecosystem services and the well-being dimensions, particularly reduced household income and deteriorating mental health, are strongly affected by plastic pollution. We also looked at the fiscal burden of flooding due to unmanaged plastics in the environment and found that the cost of inaction to put in waste management instead of leaving the drainage to be blocked, the cost of inaction is 15 times more than the cost of action. Human behavior, we have waste management, which is driven by social norms, community attachment, perceptions on waste that nature will fix itself, lack of formal waste management, cultural and religious beliefs, and that purchasing is driven by affordability and easy portioning and habits. People with lower education levels and lower incomes felt connected to the natural world were less likely to buy sachets. We use living labs to provide virtual infrastructure to identify barriers to behavioural change and to test and adopt context-specific strategies needed to shift attitudes, behaviour and practice. And we found that the most important barriers were convenience, hygiene, habits and environmental awareness. Finally, we put all of these insights into our plastics systems analysis. And you can see here 5 circles. We use this systems analysis to integrate our plastics pollution quantification models upstream and downstream to create an understanding of the processes and structures needed to unravel and address plastics pollution. We also used a systems-based approach to identify the full range of dynamics, drivers and barriers to plastic pollution at a range of spatial contexts and scales. You can see here we've got the user, the business, the regulatory framework, the political landscape, technologies, infrastructure and innovation, and ecosystems of provision. So this approach helps you to build an integrative systems framework to point out the type of interventions needed. We found leakage at collection, transport, and during sorting and disposal, and that the informal sector is critical but unsupported. Prevention requires upstream redesign, which reduces marine burden more than downstream cleanups. Leakage is driven by system gaps, not just behaviour, and the impacts are ecological, economic and social, not isolated. Second, the impacts are interconnected. Plastic pollution harms ecosystems, but it also drives flooding, damages tourism, affects livelihoods and increases fiscal burdens on local governments, which rise every year. We need integrated solutions. Comprehensive strategies are needed to address social, economic and regulatory barriers in plastic waste management. We need to reconfigure systems. Achieving a circular plastics economy in Indonesia requires reshaping institutional norms and addressing investment and regulatory challenges, as well as empowering change. Moving from end of pipe to life cycle interventions is crucial. Across the workflow, one insight stood up. Marine protection begins with prevention, upstream and on land. Have alternatives to single-use plastics when waste is collected and when economic incentives support recovery rather than disposal, and when governance is aligned, the flow of pollution to the ocean could be reduced before it ever reaches the coast. Pisces showed that the ocean is not just the end point of the problem, it can be the starting point for change by following plastic from source to sea and listening to people most affected. We created a pathway for solutions that are ecological, economic, and socially grounded. And that is the real legacy of Pisces. From this work, we delivered a practical system-based toolbox. This toolbox wasn't designed to sit on the shelf. It was designed to be used by practitioners, policymakers, community organizations, and researchers. And it is already informing Indonesia's policy dialogue. So what does all of this tell us? It tells us that the ocean is not failing us. We are failing the systems that stand between the land and the sea. But it also tells us that we have the tools, the evidence, and the partnerships to change that story. If we protect the land system, we protect the ocean system and the people who depend on both. And that is the opportunity that is before us now. First, we need a policy that matches the scale of the problem. Second, we need a community and practice-based solutions that people can actually use. And third, Indonesia has the opportunity to lead globally. The world is looking for models that connect land-based prevention to marine protection. And by embedding systems thinking, standard monitoring, and cost of inaction models, Indonesia can actually demonstrate a blueprint for other coastal nations, not just in reducing waste, but in protecting ecosystems, economies, and human well-being. So this doesn't end here. The tools are available, the partnerships are in place, and we are ready to support Indonesia in turning evidence into action nationally, locally, and globally. Terima kasih.
Thank you very much, Professor Susan, for very inspiring talk. So now we will open question session or discussion session. For on-site participant, please raise your hand. You have any question? Or we have question from online participant?
Thank you. It's very informative talk and also wonderful presentation, Susan. My name is Adrianus Biring. I'm from Indonesia. Just want to ask a question about how you engage the local government in Indonesia through your research, because I think it's so many effort that scientists, foreign researchers doing the research about the marine pollution, especially for the plastic in Indonesia, especially in Bali. But still, we have a same problem or same challenge right now that everybody, I don't know what's the problem actually, but in fact, we still have like every year we have a lot of trash, especially right now in Kuta, when there a big wave coming and also all the trash also come to the beach. And yeah, so that my question is how you engage the local stakeholder, especially local government, to reduce this kind of plastic pollution through your research result. Thank you.
Thank you for the question. It's not just about, we did engage local government, regional government, and national government through our program. And in fact, our program was co-designed with the national government at the time when it started in 2021. It's not just about engagement of government to stop the trash. It's about the entire system. The government alone cannot stop plastic pollution. We need to engage all of the sectors, and all of the sectors need to work together, and all of the parts of the value chain, the plastic value chain, all of the actors in that value chain need to act together. Now, that's no simple thing. It's actually very difficult to do, but it is what is needed, and to solve the problem, not just in Indonesia, around the world. And sectors academic disciplines we need is to bring them together, which was what we demonstrated in Pisces in doing our research. What we're now trying to do is to turn that research into action. So some of our toolbox that we created, we now have some additional funding for some of those tools to be turned into handbooks. So that people can implement some of the methods that we use. I can't hear you.
Yes. Any further comment from Andri? Okay. So, any question from the participant? Any comment? No? Okay. Professor Susan, thank you very much for your insightful presentation. So, the one last quote that because this problem, the microplastic problem, is not only a part of government job, but also all of the societies need to responsible with this kind this situation for microplastic. So thank you very much, Professor Susan. So because we have a minute of time, we will end this session for this whole session. So thank you very much, guys, for your excellent presentation. Please have big applause for Professor Susan. Thank you very much.
Thank you.
And I will return the time to Madam. Thank you.
Okay, thank you so much for amazing moderator today, Dr. Pandegede Sasmita Julianto. And thank you so much for amazing and insightful material from Professor Susan Jobli. And right now we will move to next photo session, that is maybe Professor Kara still in the room.
Yes, of course, I'm here.
Okay, so first we will move to Professor Kara to take documentation. I'm sorry, maybe Professor Susan Jobli can go first for the documentation. For Professor Susan, are you ready? Professor Susan, are you still in the room?
I'm still here. I'm not sure what we're doing right now.
Okay, well, do my sound clear?
Yeah.
Okay, so maybe we can move and please prepare yourself to take a documentation prompt.
Thank you.
Okay, so I will count in 1, 2, 3. Once again, maybe 1, 2, 3. So, yep, that's all. Thank you so much for Professor Susan Jobling and Professor Kara for amazing and insightful material today. Please give round of applause to them. Ladies and gentlemen, I know we are through a long time today. So this is the time for lunch break. So now we will pause for 15 minutes. On-site participant may proceed to the designated dining area. And for online participants are encouraged to remain connected. And so maybe we can back at 13, 14. Yeah, that's all. Thank you so much.
Okay.
Ladies and gentlemen, we are honored to come back again in ICMFS 2025. We invite everyone to give their full attention as we proceed now for invited speaker session part 2. So our invited speaker this session will be delivered by Dr. Stefano Vignodelli from National Research Council of Italy and Dr. Bashir Ahmed from Institute of Forest Ecology, Slovak Academy of Sciences, joining virtually. Followed by a hybrid panel discussion moderated by Imade Dharma Raharja, FKL MFI, were both on-site and virtual panelists. So without further ado, to Imade Dharma Raharja, the time is yours.
Diversity analysis and carbon stock in different locations in the southern Bali. So recently, the topic is very hot topic in the scientific community as well as in front of the policy makers. They're discussing about the blue carbon and the andropons. The recent period due to the climate change, and climate change is increasing, and the many environmental pollution, environmental problems we are facing. So we are largely talk about the blue carbon, and it's very essential for the ecosystem services. It's very aligned to the UN Sustainable Development Goals, and then for the climate mitigation, then biodiversity, and for the resilience to the natural hazards, especially in the coastal erosion, the cyclonic storms, and other many activities. So here we have to discuss how north in the Sanur to the Pandava beach in the south. So we have a rich biodiversity in this region, from mangrove to seagrass to corals, and most of the marine ecosystem. So here we discuss about mangroves and seagrass. So the M is marked with the mangrove species and the S is a seagrass. So we have a seagrass across the coast under the Pandava, but the mangroves is mostly located in the between Sanu to Benova in the southern part of Sanu. So, and we already know about Bali's tourism ecosystem, and the northern part of the Bali is mostly focused on the tourism activities. And while the Pandava beach is a different geological settings that from the Sanur or in the northern part of the South Bali. It's a cliff beach and a very high wave energy, and it's a relatively steeper slope in the shore. So here we are used a different research framework to analyze the diversity and the carbon stocks. So we have done a systematic field work across the southern Bali using the transects for the seagrass and the quadrats for the mangroves, even for the seagrass as well. So we have did field analysis from the 10 by 10 meter in the quadrats, and we identified the species diversity and the biomass and other environmental and geological parameters. And then we have done the seagrass, the core samples for the seagrass, and the traditional allometric equation for the mangrove biomass. And then we have integrated the remote sensing technology for quantifying the larger scale biomass estimation. It's fully focused on mangroves, that how the biomass at a global scale, the regional scale in the Bali, instead of the site-specific biomass distribution. So we are going to the seagrass ecosystem, that how seagrass ecosystem in the southern Bali is distributed, and what is the environmental and environmental factors and its involvement in the seagrass distribution. So here in the Bali, we have found a high regional diversity that comprising 9 species in southern Bali itself we identified. There are many studies that they have found some other species, but very rare. But this is the 9 dominant species we have found in the southern Bali. So the Enhalus, Thalassia, and Stingo, these are the species are more dominated, while we have the mean local richness is 2.7, which means 2 to 3 species we found in each sample locations. While we come to the different locations, around 3 to 4 species we have found in each different locations. So yes, this high beta diversity, it's indicating the distinct community driven local environmental filters. That means the different locations have different species composition, different species abundance in these different locations. So that's why it's neither a homogeneous or neither a monoculture seagrass ecosystem in these regions. So there are two distinct group we have found in terms of environmental filtering. So in uh, the two is a fine sediments, which is coarse sand or mud sediments we have found in Sanur and the Benova region, while the other Pandava and Nusa we have found comparatively gravels in the sediments composition. So and this is essentially involved in the seagrass distribution as well. So yes, so we are coming to the first ecosystem group. It's in the Sanu and the Benova. So we have found Thalassia and Enhalus is the dominant in this region. So we can say these are the climax meadows, which means these are more established seagrass communities in the southern Bali. And this is the large seagrass ecosystem in the southern Bali. And for this, the growing of these two species, especially in the rich and the dense biodiversity here, is it's a stable and a muddy stand. So this environmental setting is very involved in this distribution of the seagrass community, and it's a stable slope and a high these environmental filter is impacting the distribution of these two species. And when come to the second community, community in the Nusa and Pandava, which it's a pioneer meadow. It's a it's a young location is compared to the in the first community. So we can see the absence of Enhalus. So this is one of the major species in the Bali we found in the southern region. So and Enhalus is nearly abundant this region, and it's the dominance of Simodas and rotodata. So it's saying this the species thrive in coarsen and gravel substrates where the large species cannot establish because of the wave interaction, and it's not a stable environment for growing this kind of large species. This is relatively new, and this location is establishing. So it might take a longer time to grow like the longer anhalus and other species. So and the above ground biomass in the seagrass ecosystem, we can see that Sanur and Usadwa is significantly higher contribution in the biomass, while the Benova and Pandava beach is a lower contribution. It's there are many factors are for these differences in these two distinct groups. The Sanur and Nusa Dua have comparatively higher density and the presence of Enhalus species. While in the Benova and Pandava, we had the wave interactions is higher, and the cosands are there, and the seagrass distribution is not highly dense and very coarse. So these the two factors are contributing to the differences in the seagrass ecosystem and the above ground biomass distribution as well. So, but the seagrass have very high dynamic and high distribution of seagrass in the southern Bali, but despite this high uh, ecosystem environment, there are some anthropogenic stresses are also very much influenced in the seagrass ecosystem. So we had different many studies in before that the seagrass are mainly destroyed due to these propeller craft from the tourist boats and then tourism activities. Adventure tourism is very uh, active in the Sanur and this Benawa area. So these are also impacting in this seagrass ecosystem. So so we need some, study about how these are anthropogenic pressure are impacting the seagrass ecosystem, how these can be protected, or we have the challenge to protect this diversity. Then how we can do. So these the pressure we need to study more, and for the study should be focused on how this system should be protected. So when we come to the mangroves, here we have identified the biomass using the remote sensing technology is largely focused on modelings. So here we can see the mangrove distribution. This area of mangroves were in the southern Bali, and what are the species is located in which part. So we are distinctly distributed the samples for the allometric equation and the remote sensing modeling. So there are in the southern Bali, we can differentiate the mangrove ecosystem into two different categories. One is the natural reserve, and the second one is a reclamation mangrove. So the Soneraceae alba, one of the dominant species in the natural forest, natural ecosystem, while the rhizophora, the species are largely regeneration mangroves. That it's these locations are mainly due to the government policies and the mangrove reclamation. So we have found 12 species from different locations. So total we had 77 sample locations in the southern Bali, and so yes, the seaward pot we found the Soneraceae alba and Rhizophora in the mid zone, and the landward Exocaria gallica was the dominant species in the landward side. So yeah, so in the based on the zonation and the distribution, the seaward zone we have found Soneraceae alba and Avicennia alba has the higher basal area, so which is the oldest mangrove species, mostly dominated in the seaward zone. Even there are the dominant and the monoculture region we found in the seaward zone. While in the mid zone, in the center part of the mangrove regions are we found a very dense stand and the fastest growing region, and the rhizophora species are more dominated in those regions. While in the landward zone,
Sorry,
it's a low
Basit,
density.
your time 10
Yeah,
your time 2 minutes left.
yeah, sure. So it's almost finished. So in the landward zone, we have found the lower density and mixed species and often impacted by the anthropogenic activities. So yeah, the biomass contribution it's also it's signifying the species diversity. So Soneraceae alba had the highest biomass contribution, followed by the Rhizophorum coronata and apiculata. So yes, the Soneraceae alba is the primary carbon shareholder in these natural stand in the Benova Bay, while Rhizophora and Rhizophora species as well contribution is significant because it's a relatively younger stance in compared to the Soneraceae alba. So we have done and remote sensing integrations for the modeling. So we have used two different satellites, Sentinel and Landsat, Sentinel have 10-meter and Landsat have 30 meters. So we have done a different analysis for two different remote sensing, and we have used a random forest algorithm along with different remote sensing indices. So why, instead of focusing a single remote sensing indices or the single speed bands, we used multiple indices, so we can see the how the remote sensing spectrum and the combination of spectrum have reflect different uh, characteristics in the tree canopy. We can see the chlorophyll index and NDVI have a different uh, story. We have very differences in the spectral values, both NDVA and the chlorophyll. So we need a integrated framework with different spectral indices and different bands. And we have acquired more than 90 percentage correlation with these models. So the carbon stock, when we talk about the carbon stock, we found in the total above ground biomass stock from around 1 million metric ton. But the average we have found around 79 million metric ton per hectare in this area. So the main significant, the higher density of mangroves we have found in the center part. So it's obviously that higher biomass also found in the core areas. And while very low mangrove or biomass contribution we have found across the area where land and mangrove interaction or the more human encroachment or human interaction have involved. And why this study is important for the marine protected areas or the carbon ecosystem, we have a major contribution for the sustainable development goals by the UN organization. So there are three major SGD group we are contributing here: the climate action, life below water, and the decent work. So when we are talking about the Bali's tourism industry, so we need a sustainable tourism practices and fisheries livelihood for future future society or future in the future coming years. So, and we need to focus on for this ecosystem management and even for seagrass or mangroves, or even within the seagrass or within the mangroves, we need a space or site specific uh, integration or conservation or management strategies, because they're all the different locations have facing different environmental situations, different ecological distribution, and different anthropogenic activities. So we need a site specific management or conservation strategies for the protection of this vulnerable ecosystem. So yes, the one size does not fit for all. So it's a common theory. So we need a site-specific management focuses, and effective pollution control is required for this protection of this vulnerable ecosystem as well, because there are a lot of pollution activities we could find in the southern Bali in this vulnerable ecosystem. So yes, we just come to the conclusion. So we need Bali is a host of diverse and high biomass blue carbon ecosystem, which is very relevant for the Indonesian carbon stocks, not only for the Bali or in the Southeast Asia as well. And the seagrass communities are structured strong environmental filtering, leading high turnover. So we need more site specific and based on this environmental filtering. Mangroves in the Bano Bay hold a significant carbon stock effectively mapped, and we need this technology for it's a larger regional scale for specifically for the Indonesia and Southeast Asia. So this kind of modeling will be very relevant for the conservation and management for this coastal and marine ecosystem. And yes, site-specific management is non-negotiable, and it's for effective conservation in this high-pressure anthropogenic landscape. Yeah, and this is just a part of our theme we have involved in this study. So actually, this project is funded by the Udayana University in 2023 and 2024. So almost 1.5 year we have involved in this study with Pak Karang, Pak Nuarsa, and Hendravan, and then Surya. Then we have professor from India, Arvind Chandra Pandey. So we had a group of collaborators involved in this study. And thank you. And I welcome some questions if from the audience.
Okay, thank you so much for the interesting presentations. Now, time to discuss. Any questions? Any question to Dr. Basir?
If no
If
question,
no,
maybe I have comment.
uh, yeah.
Yeah. Okay. I think students still try to find out about the topic. Yeah. This is not question. I think that's comment. Thank you, Dr. Basir, for your presentation and for your kind time arrangement for this conference. Yeah. I think what you have done and team is very already almost comprehensive uh, for our seagrass and mangrove in certain part of Bali area. So I just want to make sure this collaboration will continue for our future between university and also your institution now in Slovakia. And maybe can you give me a idea what we will have what we will doing in the next future? Maybe some idea come up on your mind based on this result.
Yes,
Thank you.
yes. Actually, now we are working on this multispectral and this at the large scale study. But for a effective forest inventory mapping, we need a more sophisticated study in Indonesia, particularly because Indonesia have a vast mangroves tropical ecosystem. So, LiDAR-based, both terrestrial and airborne LiDAR-based study will give more uh, uh, dynamic and more sophisticated information about the forest structure stand-based with the tree-level study. Now we are working about a stand-based or the regional-based study. So we need to focus on individual tree-level study, focusing the high resolution LiDAR and hyperspectral remote sensing, which will give us more information about the ecophysiology of the species as well as of the inventory of this forest ecosystem.
Okay. Okay. Yeah. I think it's good. Ecophysiologists with a more sophisticated instrument will be great. Thank you, Dr. Basir. Thank you. So stay healthy in Europe. Thank you.
Okay.
Thank you
Thank you so
for
much.
giving this opportunity. It's been working in Udayana for nearly for 2 years, and I had a very good interaction with the students, and they were working with us. I miss many students in the photos because I didn't had, but there the more than this photo, the students from this photo have worked with me in this project, and it's been nice to being part of this program because it's our work. I contributed most of the time in Udayana, and it's an opportunity to present the same work here. Is a great pleasure to me. Thank you.
Okay, thank you so much, Dr. Basin. So interesting presentations. Yeah, yeah, especially thank you for Dr. Sipano, Dr. Basin. So interesting presentation and interesting material, even though the time is limited, but yeah, we can understood the material, and I hope we can keep in touch and still work together also in the future. Yeah, because the time is limited. Maybe for now I will return the time to the MC now. Thank you.
Okay, thank you so much, Mr. Dharma, for amazing moderator today. And thank you also for Dr. Stefano and Dr. Basir for insightful presentation today. So next we will move into photo session. So I will check if Dr. Stefano and Dr. Bashir is still here.
Yes.
Okay,
Yes,
so first, okay, good. So first we go to Dr. Stefano. Yeah, please prepare yourself. And then the committee will take a photo.
Sarung BHS sudah ada sejak tahun 1953.
One,
Iklan
two,
YouTube merupakan
three. Once again. One, two, three. Okay, thank you so
Sarung
much,
BHS
Dr.
sudah ada
Stefano,
sejak
for amazing presentation today.
thank you to all of you for the great organization.
Yeah, thank you so much. And then we will move to Dr. Basir for take a documentation. Please prepare yourself. Okay, so the committee is ready. One, two, three. Once again, one, two, three. Okay, thank you so much for amazing sessions. And we will move to another occasion. Ladies and gentlemen, we now begin the parallel oral presentation session part 1, conducted in a hybrid format across 4 rooms as a virtual breakout channels. So for the first room is the sub-theme, supporting aspect of innovation and social science, number 1 until 10. Will moderate by Made Dendi Pratama, SPT MSc. For the second room is the sub-theme, management and conservation of aquatic ecosystem, called MAQUA, number 1 until 12. Will moderate by Iputu Gede Eka Handrayana Putra, FCD MSc. For the third room is the sub-theme, sustainable utilization of fishery resources, code SURF. Number 1 until 11 will moderate by Dewa Ayu Angga PBNI SPIMP. And next, for the last room, that is a fourth room, have sub-theme, marine environmental health and treat with code MIHAT. We have number 1 until 8. Will moderate by Iputu Ranu Fajar Maharta FK MSI. So for online participants are kindly asked to enter the appropriate breakout room according to their presentation schedule. For online presenters, should check their microphone and screen sharing setting prior to their session, please. Thank you.
Sharing cake nih coba. Oke. Di unstart screen. Ya.
Sudah, Pak.
Joining to this room or no? Like first, Kamisa Ahmad. Do you join in this breakout room? Oh yeah, I see.
Yeah, Kamsia.
Yeah, Kamsia, sorry. And then Ayu Zalfitri.
Yes.
Okay. Fitriani from Pajajaran University. And then Gede Hendrawan from Udayana University.
Yeah.
Hello, Gede Hendrawan.
Yes, here. Sorry, can you hear me?
Yeah, thank you. And then Made Dharma Raharja.
Yes, I'm here.
And then Nurul Azizah from UGM.
Yes, sure.
And then Made Narayana. He is offline here in the on-site in the room. Okay, thank you. First, on-site participant are request to keep mobile device on silent mode. And then for the online participant, may submit the question through the Q&A function. Please indicate the name and of the presenter you are addressing. And then for the presenter, remind to adhere strictly to the allotted time. I will provide a gentle reminder when the time is almost up. Let us now begin the session. First, our first presenter is Mr. Kamisa Ahmad, with presentation title is Detection and Identification of Microplastic from Aquaculture Fish, a preliminary result for the health and consideration. For Ahmad, the floor is yours.
Thank you. I am not Mr., but I'm
Sorry, Miss.
Mrs. Okay, I'm female. Nice to meet you all. Thank you for the invitation. So I'm gonna share my screen. Can you see my screen?
Yeah, we can see.
Okay, I will begin with my small research. This is part of my PhD thesis in Australia. So about detection and identification of microplastics from aquaculture fish, preliminary result for the health considerations. So the overview of these presentations includes introduction, research aim, methods, results, and discussion, conclusion, and further potential research. So today, plastics are everywhere. Okay, plastics are everywhere, and the invention is actually started in the 18th centuries, and originally from billiard balls, the very top game at the time, that using ivory of. In just a few decades, plastic production has an extraordinary growth, more than 400 million tons annually, and it is predicted will increase over time. So some polymers cannot be degraded. Even are degraded, it takes 10 to 100 years to limit them from the environment. So it is very dangerous, as shown in this table. Many end up in the marine shorelines and increasing the global concern about plastic pollution. So as we know, we all already know that the macroplastics, the bigger plastics, are degraded by physical, chemical, or biodegradation process, and it became microplastics. So the classification depends on the size as this, and we define definition of microplastics are synthetic particles less than 5 millimeter in diameter that commences from primary and secondary sources. And this is the sources and the types of microplastics that have been published in many references. And this is the concentrations through marine water, say, of the marine biota. So this is some impacts of microplastics, and this is for marine life. So the aim or the objective of my study is to detect and identify the presence of microplastics in the digestive tract of fish, to determine the effects of microplastics on fish behavior, and to assess the fish resistance to plastic polymers exposure. So I conducted experiments in the laboratory at Southern Cross University, where I am currently studying. And I made 4 polymers of the microplastics: low density polyethylene, high density polyethylene, polycarbonate, and polypropylene. And then I prepare formulated fish in Indonesia, in my home base in Hiron University in Ternate. So I mix with the microplastics I prepare, and then I also set up the experimental design. I use fingerling fish, Tilapia nilotica. But before that, the most important thing, we have to do recovery, what we call recovery rate experiments of spiking microplastics. The objective is to validate our method that we can use in the field. So I did it in Australia, and this is, I tested some spike microplastics and tissue digestion process of the fish, and I found that 99% recovery rate. So I can use this method to the field. And this is the experimental procedure. I use 15 aquaria, and I have 5 treatments. treatment A with
2 minutes left.
mixed with LDPE, and B, C, D, and E. And then I use fish. I fed fish 2 times daily for 28 days, and I weigh and measure the length weekly, and I check the water quality parameters. And this is the protocols of the digestion process. And I also do a histopathological observation. So this is the result. I hope you can clearly see. So during 28 rearing days, fish in all treatments had abnormal body appearance except treatment E as a control. While on their tails, mainly on treatment C, indicated an aggressive behavior occurred. However, it is needed actually observe whether it is caused by starvation leading to cannibalism or other causes. So also agonistic behavior happens when fish in the aquaria touch and cling to one another. It is probably due to an itchy feeling on their skin or the proliferation of bacteria. So many fish scales came off. The growth among fishes is significantly different. That can be seen in this picture. And survival rate is 100% except for treatment A, and the total body length is also significantly increased during rearing period except treatment E. And interestingly, all treatments saw greater increases in body weight than the control. It is assumed that all spiking microplastics consumed are deposited in the body actually and gain weight, but I may say definitely it is not healthy. Why? Because at a certain point, the compacting of microplastics filling the gut can block the digestive systems, damage or lesion the gut, decrease feeding rate, reduce growth, and ultimately lead to mortality. So this is the reason of it is not healthy. And also, because microplastics cannot be converted into energy for metabolic activities. So another reason is also that fish may have a full stomach, but it contains more microplastics than food. So then starvation of hungriness of still happens and interferes with behavior or even neural systems. So in histological observation, all treatment with microplastic application show tissue damage, whereas the control remains normal, this E control. So we can see from this picture, some microplastic species are trapped, which have size between 10 to 50 micrometer. This is too small, probably you cannot see clearly. So this is the most important thing. We have to do a quality control and quality assurance. So we prevent using a plastic apparatus in every stage of a sampling process. And we cover samples and solution with aluminum foil or lids. So we wear coats made of 100% cotton, and the bench is always clean. And we have to do parallel run blank experiments. So we investigate the possible contamination or not in our stage. So overall, we conclude that microplastics were detected in the gastrointestinal of fish and decreased the total survival rate. Mostly fish microplastics fed increase their weight excessively and continuously. Aggressive and agonistic behavior appear during the rearing time among fish indicated by the wounds on tails and skin. So there are further required research to be done. So we have to assess the turning point or lethal time of fish after excessively consuming microplastics. So testing the dose or lethal concentrations of microplastics exposure to fish life. So thank you for your attention, and I acknowledge my
Thank you,
supervisors and students.
Mrs.
Yeah, thanks so
Ahmad.
much. If there is any questions,
Okay,
please
this is
free
a
to
highly
ask.
compelling as we never imagined that microplastic could be found inside this fish. This research is provide important foundation for raising public awareness about the plastic
Yeah,
pollution to the
yeah,
ecosystem health
mainly,
and food safety.
yeah,
Okay,
mainly for fish
now we will
consumption.
open the Q&A session. I think we need one question from the participant. Please raise your hand. Anyone want to ask question in this room? No? Okay. Mr. Ade, please.
Hello, Dr. Kamsiah Ahmad. Can you hear me?
Not doctor yet.
Oh, no,
Still
doctor.
studying. Thank you.
Okay, I just curious, what was the treatment A? Because I saw the graph, I think it has the worst result after they consume the microplastic.
Yeah. So the treatment is only the different of polymers type of microplastics. So for treatment A is low density polyethylene. So because there are 4 treatments, LDPE, which is low ethylene, low density polyethylene, and high density polyethylene, polycarbonate, and polypropylene. So that's the type of the plastic polymers.
Okay, so the treatment A has the worst effect.
Yeah.
Fish
So
growth.
so I don't know why.
Yes.
Probably because, yeah, the type of the plastics is like hardest than others. So fish cannot consume properly.
Yes, I think it's very interesting
Yeah,
because also our student check the gut of like a pelagic fish.
Yeah.
Here in the local market, and they found some microplastic on the digestive system.
Yeah.
After seeing this, your result, I think I'm a bit
Yeah.
scared of this microplastic problem.
Yeah, that's only experiment, but we have to be really concerned and consider about the methods, because that's very important about the methods. When you do a wrong method, you will get also wrong result. Yeah.
Okay, thank you.
Yeah,
Okay,
thanks
thank
for the
you,
question.
Mrs. Ahmad and Mr. Ade. And then for the next presenter is Miss Ayu Zalfitri from Pajajaran University. The time is 7 minutes. The floor is yours.
Okay, hello everyone. Good afternoon. I hope you're doing well. Thank you very much for joining today. I'm very excited to present my presentation titled Identification of Microplastic Content in Gowong Snails, Levis Thrombus turturella on Penyengat Island, Tanjung Pinang City. Before continuing the presentation, I'm honored to be able to stand in front of you all. My name is Ayuzal Fitri. I'm from Marine Conservation Department, Faculty Fisheries and Marine Science, Pajajaran Universities. So I'm honored to be here at the International Conference Marine Fisheries Science 2025. To start, let's do stage with an outline for this research. Okay, the first one I will tell about the introduction, and then the second is methods, and then result and discussion, and the last one is conclusion. So the first one is imagine your favorite ocean animal swimming along in the sea. Now, do you remember last time when you go at the beach and you leave your plastic bag did or didn't pick your trash and left it flying towards the water? Well, today I'm here to tell you the effects of doing this. So, when plastic ends up in the water, it dissolves into smaller pieces called microplastic. We can see in the right page, in this page, uh, microplastic continue to increase every year and are spreading throughout the world. We can conclude if we don't kill the microplastic, they will kill us slowly. Okay. Plastic waste in the water is estimated to reach 250 megatons by 2025, according Wright and Kelly 2017. And degraded plastic will settle in sediments and potentially be ingested by aquatic biota, including endemic biota such as gonggong snail. So gonggong snail are commonly found on Penyengat Island, one of the famous island and other favorite tourist destination, and a major maritime transportation route. So it making potentially vulnerable to plastic waste pollution. This is a sneak peek picture of Penyengat Island and Gonggong Snail. So in the first picture is Penyengat Island, located in the middle of the sea. And then the second is Gonggong Snail Monument in Tanjung Pinang cities. And then the third is batik, local batik name is Batik Gonggong from Rio Island. And then this is various ways to consume gonggong snails. In the left is gonggong boiled, and then the right is processed product into kerupuk. Okay, we're talking about methods. So this is research procedure. In a research procedure, divide into three parts, such as sampling, laboratory analyze, and data analyze. So the first, I'm checking the water quality, such as temperature, pH, current, and salinities, and taking a sample of gonggong snail and sediment. And then gonggong snail and sediment samples dried using oven at 60 degrees. And then for the laboratory analyze, we analyze sediment type using the Wentworth scale. But before that, we sieve the sediment using a shift checker. And then we analyze first using Gradistat, software Gradistat version 8. And then separation of sediment sample density using natrium chloride solution. And then the both of sample treat with hydrogen peroxide and iron 2 solution to remove organic material, and filter the sample using a Wetman number 42, and identification abundance, type, and color using Zeiss microscope. And the last one is analyze data using one-way ANOVA with a significance level of 5%. So this is general condition of research location. Station 1 until Station 3 are a coastal area, but in Station 1, many human activities. In Station 2, a little human activities, and Station 3, rarely any human activities. So result and discussion. So in water qualities, we have four parameters such as temperature, current, pH, and salinity. So if we can see the table, the temperature, pH, and salinity of the station 1 and 2 more high than station 3. But in station 3, the current is more high than station 1 and station 2. Next one is sediment type.
2 minutes left.
Station 1 and station 3 are dominated by silt, while meanwhile the station 3 has a larger percentage of sand. Okay, this is abundance of microplastic. As we can see, station 1 has the highest abundance of microplastic due to the high human activity at this location. Furthermore, this station has a low current, allowing the microplastic to settle perfectly in the sediment. In contrast to station 3, where strong currents result in relatively small amounts of microplastic. For the type of microplastic, the most commonly found is fragment, film, fibers, and pellet. Okay, this is the type of microplastic: fragment, film, fiber, and pellet. Microplastic color. Microplastic color in this station is black, transparent, brown, yellow, blue, and green. This is the reason why microplastic black and transparent most found in gonggong snail and sediment. So the conclusion is microplastic were found at all research stations. The highest abundance of microplastic was found at station 1 and the lowest at station 3. The most common types of microplastic were fragment and film, and the dominant colors are black and transparent. Okay, that's all. Thank you for your opportunity. Good afternoon.
Okay, thank you, Mrs. Ayu. Your finding provides strong evidence of microplastic contamination in both of the Gawang snail and surrounding sediment at the Panyangan Island. Okay, the next session is Q&A session. Anyone want to ask some question, please?
Yeah, I would like to ask.
Okay.
Good presentation for Ayu. I wanna know why you choose iron for your chemicals. Is it for saline solution or density separation process? And when you use the microscope, how to separate, how to distinguish between the organic materials and the plastics? Because yeah, that's very common issue when you do identification process. Thanks.
Okay, Miss Ayu, this your time to answer.
Okay, why I use the iron solution? Because I try so many solution before, but only iron 2 works for gonggong snail. For the densities, I'm using a safety pin to uh, um, to to separate the organic matter and microplastic.
Okay, because iron, the color iron is orange, right? So it is quite difficult to identify microplastics in that color. But yeah, anyway, thank you for your answer.
Okay, thank you. Maybe Miss Ayu can and Mrs. Ahmad can discussion, okay, with, by email or something, because I think you two have some interest about microplastic in the habitat. Okay, for the next presenter is Mrs.
Fitriani from Pajajaran University with presentation about the research topic about abundance and characteristic of microplastic and sediment of Karangsong Indramayu Mangrove Ecotourism Area. The time is yours. Maybe Miss Fitriani have a problem to share the slide. Can the operator share the slide, please? Hello, Miss Fitriani.
Hello.
Do you hear?
Can you hear my voice?
Okay,
I'm so sorry, I'm
we
getting
can hear
some
you.
trouble to share screen. My
Okay,
PowerPoint.
our operator will share the screen, your presentation. Fitriani. Oh, PDF. Okay, Ms. Fitriani, can you see your presentation?
Not yet.
Yes, yes. No, no. Yes, the presentation. Okay, you can see Ms. Fitriani.
Thank you. Thank you for
Okay.
helping me. A good afternoon for all participants. It's truly an honor for me to here today and to have the opportunity to present my research in this conference. My name is Fitriani from Pajajaran University, and I will be presenting a study with title Abundance and Characteristic of Microplastic in Sediment of Karangsong Indramayu Mangrove Ecotourism Area. Next. Okay. Indonesia ranks second after China as the largest contributor of marine debris in the world. And then the source of plastic waste in Indonesia water is estimated to originate from land-based activities like ecotourism and aquaculture, which then flow into the sea through a river and waste carried by current from outside Indonesia. And then plastic will be break down into small fragments or microplastic. Plastic decomposition takes around 100 until 100 years. And then the sediment is considered the main storage for microplastic because the rate of transport in sediment is lower than in the water column. Next. Okay, this is the method. The screen shows a map of the research location with 3 station points. And then the red point is Karangsong Beach. The blue point is the mangrove ecotourism site. And the green point is the Song Estuary. The sampling method and laboratory analysis can be seen on the screen. And data analysis was performed using one-way ANOVA with a significance value of 0 or 5. And the next. Okay, this is the result. General condition of research location in 3 locations. The first mangrove ecotourism, the search, the slide before. Okay, the source of pollution in mangrove ecotourism. are tourism activities and tributary flow, and then source of pollution in Song Estuary is a ham industry producing salted fish and batik. And then the Karangsong Beach have a source of pollution are tourism activities, estuary inflow, fishing activities, and ship traffic. Next. Okay, this is the sediment type that I found in the location. The sediment fraction concentration table can be seen on the screen, and we can see that the mangrove ecotourism and Song estuary ecosystem have higher mud fraction, while Karangsong Beach has a higher sand fraction than the others. And then the high concentration of mud at mangrove ecotourism and Song estuary is caused by the low flow velocity in this area, which is unable to transport larger sediment particle. In line with Takwa et al. 2014, area with low current are dominated by mud substrate, while area with strong current are dominated by sandy substrate. This is because strong current cause sand to settle at a faster rate. According to Tumbo et al. 2022, the strength of the flow velocity can affect sediment transport. Okay, next. Okay, this is environment quality. We can see that the highest average temperature is Karangsong Beach with a value of 33, and the highest potential of hydrogen also in Karangsong Beach with a value of 7 of 75. And then the temperature affect microplastic abundance through photooxidative degradation process, whereby the resulting degradation particle enter the water through currents. Potential of hydrogen is a chemical parameter required by microorganisms to carry out microplastic degradation process. The potential of hydrogen value of a body of water can be influenced by several factors such as rain and waste discharge into the water body. Next. Okay, this is current. Current velocity value at the research site range from 0 of 51 to 0 of 57 meter per second. And the current are a physical factor that play a role in transporting microplastic, and particle accumulated in bottom sediment can be spatially redistributed by currents to surface sediment. Next. The abundance at each station is presented in the following graph, and the highest abundance was found at Karangsong Beach with a sandy substrate. This is because sandy substrate have more pores, and the station receive more plastic waste than other stations. In addition, Karangsong Beach has a relatively low current velocity, leading to the accumulation of microplastic in the sediment. And then the lowest abundance of microplastic was found at the mangrove ecotourism, because in this location has a low human activity, as tourism activities are only open on just in holiday, resulting in less material to be degraded. Mangrove area have a physical function as wave breakers, reducing the currents then reach the mainland. This causes debris trapped in the mangrove roots to fragment. Microplastic abundance at the deepest mangrove boundary is lower than at the outer mangrove boundary. Next. Okay, this is microplastic tape that I found. Fragment, film, and fiber. And then fragment are a type of microplastic that originate from large pieces of plastic that have undergone degradation due to UV light. And then fragment is the type that dominate in aquatic environment, is caused by the dominance of high density microplastic on coastline or
1 minute
shoreline,
left.
as plastic bottles or houseline plastic. And then the high abundance of film at mangrove ecotourism. This is because film has a low density, and then make the film easy to flow in the mangrove area. Next. This is microplastic size. The dominated size of microplastic at this station was less than 1 micrometer. And according to URAS-GIVA et al. 2020, area with the high microplastic concentration to be dominated by small particle. And then the microplastic size is also a major factor related to the extent of its effect on organism. Next. This is a color that I found. There are 7 colors: yellow, brown, transparent, blue, green, red, and black. And then the color of microplastic can provide information about the source of waste pollution on the condition of the microplastic. Next. Okay. Next. Okay, conclusion. The highest abundance of microplastic was found at Karangsong Beach with a concentration of 87, and this is due to human activity at this station, calm current speed, and high temperature. And then the 3 stations were dominated by fragment and film. And then the size of microplastic at each station was less than 1 micrometer, and then the colors with the highest number were yellow, black, and transparent. Thank you for the time.
Okay, thank you. Yeah, it's a good presentation with this topic, and then we next to Q&A session. Please, one question. If no one question, I will ask to Ms. Fitriani. I will ask, I'm interested in how you link the microplastic concentration in sediment with ocean current. I would like to ask you your perspective on microplastic that are transported by current and eventually end up in the marine sediment.
Okay, thank you for the question. How current, take the microplastic in the up of sediment, yeah, like that. It just
yes. Yeah, please.
Okay. Zhang 2070 state that current has the surface current have a major influence on the horizontal transport of microplastic with high velocity, more than 2 kilometers per hour. And then, yeah, in the slide. And then the particle accumulated in bottom sediment can be spatially distributed by current to surface sediment. The higher the current velocity, the more difficult it is for microplastic particle to settle into the sediment, thereby reducing the abundance of microplastic in the sediment because the high current velocity will pull the microplastic, the sediment, back into the water column. Maybe that's the answer.
Okay, thank you. It's your perspective about the current affect the microplastic transport and end up in the sediment. Okay, we'll go to the next presenter is Mr. Gede Hendrawan from Udayana University with the topic, the title is Microplastic in Organism Within the Coral Reef Area of the Karangasem Conservation Area. Please, the time is yours.
Okay, can you see my screen? Sorry, can you see my screen?
I think it's loading.
Okay.
Can the operator help to share the... Oh, yeah, we can see now.
Okay.
Presentation. Okay, your time
Okay,
is 7
first of
minutes.
all, thank you for the time. Yeah. Okay, first of all, thank you for the time. And I'm sorry that Pak Gede Hendrawan is not attending at the moment. So I am Ade. I will be representing on behalf of Pak Gede Hendrawan for his research titled Microplastic in Organism within the Coral Reefs area of the Karangasem Conservation Area. Okay, so I will go straight to a little bit of introductions. So it also has been stated this morning with Ibu Nani that Karangasem is also impacted by the ITF or Indonesian Through Flow, or in Indonesia we call it Arlindo, that is carrying a huge mass of waters that also containing plastic pollution that brings around 10 tons of litters into the Karangasem area, which is marine protected areas. And as Bali's second largest fisheries production area, Karangasem faces growing risks to marine life and local livelihoods. And this study is aimed to assess the abundance and polymer types of the microplastic that is ingested by the reef fish that is inhabiting this coral reefs area. So for our research, we do the fish collection using a spear fishing method around the coral reefs areas, and we also identify the fish, and we do sample preparation, we extract the digestive systems, and we do the microplastic extraction from the digestive system using the method from Rahman et al. 2015. And after that, we do the sample analysis, we identify and quantify the microplastics, and after that, we analyze the polymer using Raman spectroscopy. So for the result, so we collected around 20 samples or 20 fish that represent 14 species in various size, and we got here as you can see, and based on this 14 species and 20 samples that we got, 50% of the fish is carnivore fish, 25% is omnivore, and 25% is herbivore. So the microplastic we found in the fish digestive systems, we found 4 types of microplastic, that is fibers, films, filament, and fragments. And based on the total of 258 microplastic particles, in all 20 samples, we found fibers and fragment only in 2 samples, and film and filament in 1 samples. With 97.7% of the microplastic is fiber, and 1.2% is fragment, 1.8 is film, and 0.4 is filament. So we analyze the feeding type interaction with the habitats, and with it how it's connected to the microplastic abundance on the fish gut. So here the box plot shows that the distribution of microplastic concentration across different feedings type of reef fish, and herbivorous fish exhibit the highest median value and the widest range, indicating greater microplastic accumulations and variability among individuals. This may be linked to their feeding habits as they graze on algae. Okay. They graze on algae and substrate where microplastic often settles. For the carnivorous fish, shows moderate level with less variations, suggesting that the exposures occurs mainly through trophic transfer from prey. And the omnivorous fish have the lowest and most uniform concentrations. It's possibly due to their mixed diet. And overall, the feeding behavior strongly influence microplastic ingestions, with herbivores being the most affected group. And for the scattered plot shows the relationship between the fish length and the microplastic concentrations. And the trend line indicates a weak positive correlation, meaning that as fish size increases, the microplastic counts tend to rise, but only slightly, and the relationship is not consistent. Small fish contain relatively high numbers of microplastic, while certain larger fish had fewer particles. This suggests that body phase alone is not a reliable predictor of microplastic ingestions. Next, this is the polymer identification. So 8 representative microplastic were sent to the laboratory for polymer identification. So there are 3 sample of fibers, each sample of filament and film, and 2 sample of fragments. So from the fibers, we found 3 different polymer, which is the polyester film, isotactic polypropylene, polyethylene terephthalate. And for the filament, it's polyester film, and in the fragment, it's polyacrylonitrile and polyester-based materials. So this is the common use or possible sources of the polyester, PET, and poly. Okay. So yeah, actually, we haven't finished our analysis yet. So if anyone has any ideas or suggestion on what kind of analysis that could be interesting to explore with our data, we'd be happy to hear them. Thank you.
Okay, thank you. Sorry, with Miss Ade, yeah.
Yes.
Okay, I open the Q&A session. Please, one question from this room or the online meeting room. Anyone?
I'm going to ask again.
Okay.
This is,
Please.
yeah, okay. Because this is very interesting. So you are doing also the identification in the digestive system.
Yes.
So I'm wondering because I saw your result is not quite good, which is in the filter paper, right?
Yes, it is in the paper.
So what saline solution do you use for the for the process, like in the methods?
In the method. Okay, please wait. I'm not quite remember but we use a lot of
Yeah, the
solution.
chemicals.
Sorry,
The
please wait a
chemicals,
moment.
like there is like not peroxide, but
Sorry, wait, I
chloride.
will.
Yeah.
Okay.
Do you mean
please
the
wait.
microplastic in the Watman filter trapping here and how to spread it?
I'm still searching for my because I'm
Yeah,
not
because
remember all of the solutions. So okay.
yeah, because the result I saw it's not quite good, so you cannot like separate it between the filaments and the fragments on the top of the filter paper. So probably because of the saline solution you use at the first, like the initial step. So I suggested you have to make sure first is the density of the saline solution. So I mean, because you want to see which one of the microplastics can be floated, right?
Yeah.
So
So
yeah.
we use H2O2 solution and we use the KOH. At
Okay.
first, we use KOH
Sodium hydroxide.
solution. Then to destroy the remaining digestive extract, we use the H2O2 solutions.
Oh, hydrogen peroxide.
Yeah.
Okay. Yeah. Okay, thanks.
Okay, thank you. Oh, all of this is microplastic, ya. Ibu Ahmad. Okay, we move to the next presenter. Is Made Dharma Raharja from Udayana University. With the presentation title is Assessing Marine Debris Transport and Source in Nusa Penida Marine Protected Area through 3D Numerical Modeling. Mr.
Okay.
Dharma,
Yeah.
time.
Okay. Could you see my screen now?
Yes, we can see.
Yeah, for the first, thank you for these occasions. Today I would like to present my primary research about the marine debris. Yeah, for this case, I focus on marine protected area in Nusa Penida using a numerical model. Yeah, this is the background why I took this case, because in the past we found a lot of plastic and marine debris around the marine protected area. I think so very important to analyze with the numerical model. Yeah, we know the condition of the plastic is very complicated, and yeah, we in the world maybe we always produce a lot of plastic, around 415 million tons per years in the world, but 3% is leakage to the environment, and yeah, this is the problem. Because of this leakage, maybe our condition for the biodiversity, for the ecosystem is very dangerous because of the plastic conditions. And based on the previous research, based on the Jambek, they said the condition of the plastic around 80% coming from the land. Yeah, based on that, because of the leakage, and there are a lot of plastic produced in the world, and in the world also have a connection from the land to this from the land to the sea, have a connecting, and because of the current, I think is very make condition of the plastic can move from the other side to the other side, and because of the currents can make the particle of the marine debris also can stand it in the coastline maybe. And yeah, based on Jambek, they said the condition of the plastic coming from land, and yeah, we also from Udayana also has had a experience and made a analyzed from the river. Yeah, we found a lot of plastic. This case based on the Pisces project. Yeah, this is the river in Banyuwangi and Jembrana, and yeah, we found a lot of marine debris and especially plastic debris. And based on that, the plastic can following the current and maybe can make can strand it also in the coastline. Yeah, we know the condition of the current Indonesia is like this. we know in the Indonesian through flow, and we know also the condition of the ocean conveyor belt. And Indonesian through flow is part of the ocean conveyor belt. If the particle coming from the land and following these currents, and in this case, part of the conveyor belt, and maybe the condition of the plastic and stranded around of Lombok Strait, especially in marine protected area in Nusa Penida. Yeah, is this correct or not? Yeah, this is correct. The condition of the plastic of the marine debris can stay or stranded in marine protected area in Nusa Penida. Based on the previous research by Germanov and Argeswara, we found a lot of plastic. Mostly, they found a lot of plastic in rainy seasons, and also around 60% is plastic debris, and 45% is the marine debris is phylum, and 31.5% is fragment. And based on previous research by Argeswara also said the condition of the polymer based on that plastic is polyethylene and polypropylene. The condition of the dose of polymer is low toxicity, but they can make the biota, or yeah, attention, can make the attention for the biota. I think we know the marine protected area in Sapeda is habitat for the manta, and manta is filter feeder, and they see also the condition of the plastic. Maybe they can eat the plastic also. Yeah, in the past, in 2018, I found the condition in the south of Nusa Penida in this area. I don't know. This is because of okay. I don't know. This is because of the plastic. Sorry, or the human or not. And but we found accumulate, and this is accumulation from the marine debris around of Nusa Penida. Mostly the condition of the plastic analyzed with numerical model with forward, but now we want to analyze with the backward. Yeah, we analyzed around of the Nusa Penida. We took a lot of plastic, and with the NOAA methodology, and we found the condition of the plastic also a lot of in the south part of the Nusa Penida, especially in dry seasons. And this is correct with the previous analysis or research by Germano for Hargaswara also. Based on that, I use a numerical model with FICOM and PyLag for analyze the condition of the particle tracking. And this is the simulations I release every 3 hours to analyze the condition of the plastic. And I also make the analysis with the observation data to make sure the model is correct or not. Yeah, this is my observation data. This is based on tide, mostly the condition of the current, and tide is river is almost same with the model. And based on that, we continue again with the numerical model. Based on that, we know the condition of the plastic or the particle coming from the Kalimantan, Java, and Bali. This is based on the backward analysis model. And yeah, the condition of the plastic, so following the current condition, especially by the seasons, and mostly they came from the Kalimantan or following the Indonesian through flow currents. And yeah, in this case, on the other hand, we also analyze the condition of the plastic with the forward analysis, and we combine or we make the comparison with the observations. And yeah, we found also the condition is so highest in the south part of the Nusa Penida, same as the numerical model. And yeah, why? Yeah, the condition is very highest in the south part of the Nusa Penida, especially in DJF or rainy season. In my perspective, and based on the research, that is because of in this area has a eddy, and when the particle come, they cannot move directly to the Indian Ocean, but they can came again in Nusa Penida and stranded also in here because of this eddy. And yeah, we know the condition is very strong in dry seasons. Make the condition of okay, just a little bit, and move the particle immediately to the Indian Ocean. And based on the previous research by some of the ministry also found the condition of the particle from Java can strand it or through the condition of the current to the Lombok Straits. And yeah, I found the condition of the current so influenced by current condition, especially Java Sea current and Makassar Strait currents, and mostly the particle coming from the Kalimantan. And mostly the condition is very highest for the marine debris in the subperdermal area in DGF rainy season because of eddy circulation in that locations. Yeah, I think that's all for my presentations. Thank you.
Okay, thank you, Mr. Dharma. Any question for Mr. Dharma presentation? No? Okay, I will not ask because I'm joined with his research. So that I cannot ask. Someone? Anyone? No? Okay. If no one to ask Dharma, we will go to the next presenter. Oh, the next presenter is me. Okay, I think I will start my presentation. Sorry. Can you see my presentation? The online participant? Okay. Okay, I will start. Operator, please keep my time. Okay, my research is about modeling of sinking macroplastic accumulation in benthic ecosystem. This is a case study in Bali Strait, Indonesia. My name is Iputurano Fajar Maharta from Udayana University. Okay, did you know 30 million metric ton of plastic reach the aquatic environment for annually every year? The source is mismanaged waste from the land, and this mismanaged waste can go to the ocean by through the river with up to 80% of plastic that reach to the ocean through the river. And then what the world is studying to describe this plastic pollution in the ocean. First, everyone know with observation using manta trawl or visual survey, maybe we can using the manta trawl to collect the plastic. Sorry, collect the plastic like micro to mesoplastic from the surface using standardized nester net, and some manta trawl can collect the microplastic too. And then the second method is using remote sensing, like a drone survey can capture high resolution image to detect the floating plastic in the local area, and then satellite monitoring. We provide a more spatial coverage and map large scale of plastic hotspot in the ocean. But these two methods, we can just see the surface water and the floating plastic. And the third method is using the numerical simulation. With this approach, we can predict the plastic transport based on the ocean current, wind, and hydrodynamic mechanism in the ocean. But if we see all this method just to the scientific community just concerned to the floating debris, while the fate of plastic that can sink to the seabed or the deep water, but this remain poorly quantified. not many research to quantify the plastic to the seabed or the deep water. I can say the scientific gap. If the plastic go to the ground and pollute the benthic habitat, you can see the same plastic represent the invisible but it's critical threat settling in the habitats of seagrass bed, coral reef, and soft bottom community. Some studies have modeling the sinking of microplastic, but no one quantify the macroplastic. That even their impact on the habitat, marine habitat can be greater than microplastic. Like this research from WIS in 2024, we can see he modeling the time evolution of microplastic go to the deep water. And then this is the research from Segal in 2024 in Levatin Basin, the microplastic litter concentration in 20 until 1,600 meter in the water depth of the microplastic. And then the objective of my research is develop a model to describe the macroplastic pollution that's sinking to the seafloor and macroplastic pollution in the benthic ecosystem. For the surface plastic movement or horizontal movement, I using hydrodynamical model same with Dharma doing using FECOM and pilot for Lagrangian particle modeling. And the source of plastic I'm using from some river in the Bali Strait. And then for the vertical movement, now I make my personal assumption or my personal framework. This is my novelty. Like first, I'm use the biofouling as the sinking trigger. With this macroplastic are assumed to sink after crossing 35-day biofouling threshold. And then this biofouling is not explicitly simulated sinking represented using the empirical sink threshold and constant settling velocity with the settling velocity use around 0.70 meter per second. I get this data from Lovely in 2024. And then my second assumption is limit the horizontal movement by resident time is more than sinking time. Is the resident time is how long the particle or the plastic stay in the one location in horizontal in the surface water, and then the sinking time is how long the plastic can sinking to the seabed. With this resident time is derived from Lagrangian particle tracking modeling, and the key rule is time for resident time is must be more than time to sinking is vertical sinking dominated. And if the time for resident time is less than the time the sinking, horizontal transport is diminished. The third assumption is vertical force balance with the combined density plastic and biofouling exceed the seawater density based on the physical condition like gravity force more than greater than the buoyancy force. Is following conceptual density balance model from COI in 2017. This is the result of the macroplastic in seabed accumulation. You can see before that I give like a context in the Indonesia. We have two seasons like a west monsoon and east monsoon. West monsoon is the wind is blowing from west, and the east monsoon the wind is blowing from east. Because of that, we can see the macroplastic accumulation in the west monsoon is around December, January, February in Indonesia. We can see the plastic is accumulated and the hotspot in the Bali area. The right picture is Bali and the left is Java Island. And in the east monsoon, we can see the wind is blowing from the east and go to the west, and the plastic accumulation in the bottom or on the seabed is accumulated in the Java Island around Banyuwangi and Jembrana in the Bali area. And then obviously, because this model is using a new assumption, new approach from my idea, I must to validate the model, and this is the result. I try to take the observation data or the macroplastic in the habitat, like in the coral reef, in the some location. You can see the correlation in the east monsoon and west monsoon is more than 0.5, and is a good correlation. And then for the benthic ecosystem contamination, I'm using a pollution load index with some area habitat ecosystem area in the Bali Strait. We can see some area have category extremely danger, and some area is high high pollutant with macroplastic in the benthic, like coral reef and seagrass. And the conclusion is the study is successfully developed an integrated modeling framework that accurately predict the sinking and deposition macroplastic on the seafloor. And the second second answer is the model is effectively determine the macroplastic contaminant level in the benthic ecosystem because we can reflect the high risk zone consistent with a pollution load index or PLE classification. Thank you. Okay, I'm back as a moderator. Any question for my presentation?
I'm gonna asking again.
Okay, thank you.
Is it okay? Okay.
Yeah.
Putu, Ranu, or Fajar, or Maharta, you have a long name.
Yeah, it's Balinese name.
Yeah, Balinese name. So I'm gonna ask, are you also consider about the polymer plastic type in regarding observing the residence time and the sinking time? Because we know like PVC, polyvinyl, PVC plastics is heavy than other like polyethylene or polypropylene. So PVC will be sink faster than other plastics. So are you consider about the type of the plastics for the sinking time?
Okay, thank you, Mrs. Ahmad. Yeah, in my research, I'm not calculating or I'm not calculating the name is settling velocity, the speed of the plastic go to the bottom. I'm not research about the different plastic, how the speed of the different plastic, but I'm using the other research with the name is COI. In some research is calculate the speed of the different plastic like HDPA, SDPA, LDPA, and some plastic. But in my research is just focus on develop framework to calculate the vertical movement of the plastic in the ocean. But if you ask me if the different type of plastic have a different speed, settling velocity, yes. So many research about this, and in this research, I'm just using one type of plastic is spare plastic, HDPE plastic. I'm not put in the presentation of this. Sorry about this.
Okay, thanks so much for your information.
Thank you. Okay, we will go to the next presenter. The next is Nurul Azizah, with the title is Abundance and Characteristic of Microplastic in Skipjack Tuna. landed at Sadang Coastal Fisheries Port in Gunung Kidul Regency. The floor is yours, Ms. Nurul.
Okay, can see my PPT?
Yeah,
Okay,
we can see.
thank you. My name is Nurul Aliza. I'm from Gajah Mada University, and in this occasion, I will present my research about microplastic in skipjack tuna and landed and studying coastal fisheries port at Gunung Kidul Regency. Okay, we know that Indonesia is a developing country with a population that increases every year. And the effect is high population growth is equivalent to high levels of waste products, such as plastic. Plastic in the environment decomposes through oxidation by UV light or high temperatures. This plastic breaks down to a size less than 5 millimeters and we known as microplastic. Microplastics are carcinogenic and contain toxic chemicals causing problems for the lives of organisms. Plastic is a type of marine debris whose species is considered the most dangerous. Microplastics are plastic particles measuring less than 5 millimeters and be found in ocean waters ranging from remote coastal areas to deep ocean waters. According to Circular Law 2023, microplastics can originate from physical process, the breakdown of plastic product into small particles that are then emitted into the biosphere. Microplastic can also originate from improperly treated waste, that the degradation of large plastic, textile, friction, and household waste. We know that microplastic type is now 6 types, and number 1 is fiber, number 2 fragment, number 3 film, number 4 pellet, and the 5 granule, and the 6 is foam. Okay, we know that microplastic have a negative impact about from organism and the human. For the organism, microplastic cause growth disorders due to false feeling of fullness, resulting in decreased appetite and disrupting the digestive metabolism of biota. And number 2, microplastic impact from microorganism that makes the digestive tract, reduce growth rates, inhibits enzyme production, lowers steroid hormone level, and affect reproduction. And from human, microplastic can impact from the chemical compounds in plastic contain carcinogenic substance that can increase the risk of cancer. They also describe metabolism, immunity, reproduction, and neurotoxicity. This result can purpose there to determine the microplastic content in skipjack tuna and landed at the Sadang Coastal Fisheries Port in Gunung Kidul Regency. And the number 2, to determine the shape, size, and color of microplastic contained in skipjack tuna and land in the Sadang Coastal Fisheries Port. Okay, is the my study area in Sadang Coastal Fisheries Port, and this results from August 2023 until February 2024. Okay, the sample collection was conducted randomly from local fishermen at the research site. 30 skipjack tuna of varying size were used as samples. The fish were then placed in a cool box filled with ice. The samples were then taken to the laboratory for further analysis. And the parameters that I see is a length and weight of fish samples, shape, size, and color of microplastic. Until the microplastic extraction, fish samples were stored at room temperature before being opened. The length and weight of the fish were then measured and recorded. The samples were carefully dissected to remove the digestive tract and then weighed. The digestive tracts were then placed into digestion beakers and recovered with aluminum foil to minimize any airborne contamination by microplastic. The extraction of microplastic followed the method described by Fukuyama et al. Using 20% alcohol solution at 3 times the sample weight. The beaker was covered with aluminum foil and left at room temperature for 14 days. After this period, the solution was filtered on Woodman number 41 filter paper using a vacuum filtration system. The filter was placed in a clean petri dish and were analyzed using a binocular microscope with 40 and 100 magnification. About contamination prevention, strict quality control measures were implemented during laboratory analysis to minimize airborne and lab contamination. All laboratory supplies were covered with aluminum foil to prevent airborne microplastic contamination. Prior to the experiment, all laboratory supplies were rinsed 3 times with aqueducts. Okay, about statistical analysis, microplastic abundance in samples were expressed as the number of observed microplastic items per individual. All statistical analyses were performed using SPSS software, and the non-parametric classical Wallis test was performed to analyze multiple comparison. All values were reported and the average of standard deviation, and then the data visualization was done with table and graphic. Okay, it's my result from the research, but the highest abundance for microplastic was observed in 31 until 34 centimeter samples, and the weight interval is the 151 until 538 gram interval. About microplastic morphology in skipjack tuna, fibers were the most abundant shape of microplastic found in skipjack tuna. Compressing is 99.6% of the total, and followed by fragment. Fibers are thread-like in various colors, and the flakes are irregularly shaped with a dark or a non-transparent color. In the length class interval of samples, the most common colors of microplastic were green, about 49% in the 31 until 34 centimeter interval, followed by purple, red, and yellow and blue. In the weight class is microplastic is the most common colors is the green, like the length class, followed by purple, red, and yellow and blue. This is my microplastic that I found in my sample skipjack tuna. That the type is fiber and fragment. With the fiber is color blue, green, yellow, black, purple, and yellow. And the fragment I found that was one more particle. Microplastic were classified the 3 categories there according to their size. In the length class interval of samples, microplastic between 50 and until 500 micrometer were the most abundant size class. In the weight class is the same of the length class, that the most abundant size is followed that 50 until 500 micrometer. Okay, is microplastic correlation. In the correlation test between fish length and total of microplastic found, the p-value was 0.112, and meaning there was no mutually influential relationship between fish length and total of microplastic. In the sum of the weight
with fish and microplastic, it is meaning there was no mutually relationship between fish weight and total of microplastic. Okay, as the all and conclusion, we conclude the skipjack tuna samples surrounded and the siding fishing port were found to contain microplastic in 93% of the 30 fish samples taken, with the fiber was most found that sample. The colors of the microplastic found were green, purple, red, black, blue, and yellow. Green microplastic dominated the skipjack tuna samples with 116 particles. The microplastic found were predominantly small in size, ranging from 50 micrometer until 500 micrometer. This is my reference, and okay, it
Thank you.
is enough for me. Thank you.
Okay, I will open the Q&A session. Anyone to ask some question? No again. In the online participant or in the room? Okay, I think we move to the next presenter. As our last presenter is Mr. Made Narayana Adibusana from Udayana University, with the abstract title is Distribution of Individual Wave Overtopping Flow Velocity and Layer Thickness on Composite Breakwater. This is an imposter in our session because not of plastic, but no problem. Mr. Made Narayana, it's time for you.
Okay, hello everyone. Can you hear my voice?
We can hear you and we can see your presentation.
Okay, so I am the last presenter and my topic is not related to the microplastic or macroplastic studies. I should be present this tomorrow, but I cannot attend the conference tomorrow. So I move to this session. Anyway, I will present my presentation very short and briefly. So the topic is about distribution of individual weight overtopping flow, velocity, and layer thickness on composite breakwater. I think you might heard about a breakwater, or in Bahasa it's called as pemecah gelombang, a structure that we found in the coastal on the coastline usually, and then there is a phenomenon called as the overtopping. So okay, so this is the picture of wave overtopping. So here the black structure here is the coastal structure. This is the breakwater. And when the wave propagate toward to the coastal structure and then hitting the structure of this breakwater, the wave will propagate to the top of the structure. And this phenomenon is called as the wave overtopping. So why this is important? The first one, the wave overtopping is transfer wave energy to the top of structure. It affect the stability of the structure. And the second one, the top of this structure or the crest usually become a tourist attraction area. As you can see this picture, which is the wave overtopping expose a hazard to a pedestrian. And as shown by some literature or report, there were accidents in the past, like reported in this paper here. There were 12 accidents in the UK as well as in Korea. So from 2010 until from 2005 until 2018, at least there were 2 accidents reportedly each year. So based on this previous study, and this is that's why this study is important. It's crucial to avoid the prototyping hazard during design to ensure the pedestrian safety And based on the previous study, the safety of pedestrian on the top of the coastal structure during the wave prototyping event is depend on the what is called as the flow velocity and the layer thickness. So this layer thickness is kind of the depth of the overtopping on the crest of the structure. So how to study this wave overtopping? So we perform what is called as the physical experimentation. So here is the sketch of the what name as the wave plum. So anyway, this is the photo of the wave plum. So this is basically just a tank filled with water, and this tank has a wave maker. We call this as a wave maker. So it's located at the front of the tank. So this wave maker is moved back and forth and will produce a two-dimensional wave. And inside this plum, we put a model of the breakwater structure. So this is the sketch and this is the picture. So this is the small scale model. The scale is 1/40. So in this wave plum, we generate wave based on the real condition where we scale down the wave height and the wave period, as well as this structure. Also, we scale down the structure. And then we run an experiment with different wave condition, and then we record the velocity and the layer thickness. So how do we, so this is the parameter that we measure during the experiment. First, we measure the water surface elevation. And from water surface elevation, we got the wave parameter, which is the wave period and the wave height. Then for the wave overtopping, we took the photos using the high-speed camera, and from the image, we determine the velocity and the overtopping layer thickness. So here is the instrument that we use. This is so the red box here show the position of the measurement instrument, which is the wave gauge for measuring water surface elevation. So this is the real picture of wave gauge. It consists of like a stick here, and they have a wire in front of it to measure the fluctuation of water surface here. And then from this water surface, we just convert it into the frequency domain. And then from the frequency domain, we calculate the wave height and the wave period. So here is how we measure the wave flow velocity. So here we measure the prototyping velocity on the top of this structure. This is the sketch, and this is how we position the camera. And this is the setup of the camera. And this is video show how the experiment was conducted. So here we have the high-speed camera, the picture of the wave overtopping. Okay, so here is the breakwater structure, and here we have a LED to create a backlight, and we capture this during the, we did this experiment in the night time, so we only kind of capture black and white picture. So here's the example of wave overtopping image. So here is the image of wave overtopping. The black here, the black structure here is the breakwater. And here we convert the image. And from this image, we get the velocity map. So the red color here is the velocity vector. And from the image, we also determine the surface of the wave overtopping and determine the wave overtopping depth. So this is the wave condition. We have various wave period and wave height over here. And this is the result of the how the velocity map looks like during the wave overtopping event. And here is the time series of wave overtopping velocity and the layer thickness. So here, as we know that the wave is irregular, so there are sometimes big wave and small wave as well. So that's why this looks like this. So this is the layer thickness of depth. And then the red circle here show the maximum value. And we only focus on this maximum value. And from this individual value, we fit into several distribution. And we found that the best distribution to describe individual velocity and layer thickness is Rayleigh distribution. Okay, actually from the distribution, we develop empirical equation to estimate the velocity and layer thickness. I will skip to the final result. Okay, so this is the final equation or formula that we can use to estimate the photographing velocity and layer thickness, especially specific for this structure. So this figure show the performance between the experiment data and the estimate data. Okay, so for the conclusion here, we found that the Rayleigh distribution give the best kind of distribution to our experiment data here. And we also developed the empirical equation to estimate the photographing velocity and layer thickness. And this equation only applicable for the structure with the range of, we call this as crest freeboard for this value and wave steepness in this condition and non-breaking wave condition. Okay, that's all from my presentation.
Okay, thank you, Mr. Ade. Any question? Okay, no, I will ask. What do you think about if we apply your design in Indonesia? Because I think I never see that this breakwater design like a Patrick star, the shape. Yeah, I see Patrick in SpongeBob. So many Patrick. Okay. Do you think we can apply it in Indonesia, especially in Bali?
Short answer is yes. So this study was conducted in South Korea. So why they use that type of, we call it armor unit, they use a concrete, artificial armor unit. But here in Bali, we mostly use like a stone. So because in Korea, they don't have many stones, so they use the artificial armor unit and that. And this tetrapod, I think there is no more patent, so they don't need pay money for the patent if they want to use this type of armor unit. Yeah, they also develop some new type of armor unit, but still tetrapod is kind of best for protecting the structure. Okay.
I think because we have the stone, we have so many stone in Indonesia. Because of that, we don't need to make a new shape or a structure. Yeah, expensive too to make this. Okay, this is our last presenter from Mr. Ade, and ladies and gentlemen, that conclude our oral presentation session. We extend our sincere appreciation to all the presenter for their valuable contribution, and to all participants on site and online for your engagement and fruitful question. We invite you to join the next session in the main room. Just leave this breakout room. Thank you very much, and we hope you enjoy the rest of the conference. Thank you.
Thank you.
Recording in progress. Recording stopped.